Okay. So this is the whole process. I hope it is visible to everyone. The process and the flow of this live session is: first, you share a question with us. It reaches us. It is allocated to a faculty member, and a time slot is booked on the call for them to come and solve the question live. Uh, During that live session, you can ask your doubts about the question being discussed by raising your hand signal on Zoom. Okay. We will move on to the next question as soon as the slot ends or the discussion ends. Okay. And we will keep the discussion strictly limited to IIT JEE Advance Question paper. Uh, so, yeah, uh, I'll stop the sharing. And I think I need to add a few more teachers. Yeah. Cool. So we have more and more students joining now. Welcome, everyone. Yeah. Got it. Yeah. So I'll walk you through the process again. I'll share my screen again. So the link here, which is this one, if you go through this link, you will reach this page. Okay. Here, the whole process is written for you. Please write the full question. That is a step one. Please write the full question on a piece of paper in readable handwriting. Okay. Then write any specific doubts that you have on that question. Okay. That's step one. Then step two is take a picture of the above and upload it on one of these links. These are Google Form links. Okay. And you can upload them there, and you need to mention your name. So if I click on this, I'll reach this Google form. Here it will ask you to submit your or log in with your Gmail account, and then you have to share your name, your mobile number, your email ID, city, and for physics in particular, these topics have been enumerated there. You can choose one of the topics, and then you can upload that picture on this link, and then you have to submit. Okay. All of these are mandatory. If you do not if you leave any of these spaces vacant, the form will not get submitted. Now, your mobile number should be correct, because we will get in touch with you in case one of the faculty member wants to understand if any missing information in the question. Okay. Also, whenever we are going to receive a question, we will share or we'll revert back with an acknowledgement message. Okay. And whenever we are ready with the time slot for uh, discussing your question on this live session, we will again share a message with that time slot. Okay. So it is very important. Now, the cutoff time to submit your questions is 10 p.m. Okay. Also, these are the links to the Zoom or the YouTube live sessions. You are on the physics live session. You can go to chemistry or mathematics live sessions in case you have doubts in those as well. Okay. And every doubt like physics, chemistry, maths, you have to submit it as many times. So without further ado, I think some people have started raising. Just give me a moment. Huh? I'll unshare first. Cool. ठीक है. I'm inviting Kalyan sir. Professor Kalyan has been with us for quite a few years. He has more than 7 years of experience, and he has in his uh, career he has sent quite a few students to the top IITs, and he is expert in discussing the heat and thermodynamics questions while he's able to do take any question from any part of physics. So I welcome Kalyan sir. You can please unmute yourself and present your screen.
Yes. Good evening, everyone. I hope you all are able to follow my audio, and my audio is clear. Am I right, Ashish sir? Yes, sir. And Ashish sir, can you please make my ID as a host so that I can share the screen? Thank you. So, dear students, thank you for turning up after spending exhaustive 6 hours of the day. Still, turning up for such sessions makes us feel encouraging to conduct more such sessions. And we have received quite a few questions from you to discuss. And one among them that I'm going to discuss is from magnetics, to calculate line integral from a point to the other point in the presence of a current carrying wire. And I request Ashish sir, can you please make me host? The other.
I have made you host, sir. Please see uh, if you're able to share your screen or not.
Yes.
You're able to? Great.
Thank you, Mr. Ashish ji. Now, we have received a question from your paper 1 physics, which looks quite simple for those who have practiced your magnetics chapter. Now let us, without any delay, let us proceed to the question. Now here, we have this question. I hope you all are able to see the question.
No, your screen is not visible, sir.
The topic is from Ampere's law to calculate line integral from one point to the other point in the presence of an infinitely long current carrying wire.
Sir, your screen is not visible. The screen on which you are solving.
Excuse me, students, for a minute.
So for all these students who are joining us from different streams, I'm sharing the.
I thank all of you for patiently waiting for the paper discussion.
Cool, cool. Are you able to share your screen, sir?
Mr. Ashish sir, can you please engage the students for a second?
Okay. Sir.
Thank you.
Okay,
Please unmute
so
yourself,
I'm
sir.
just, yeah, sir, please, yeah, take care of this. I'll share some information regarding the.
No. Ashish sir, you have
Yes,
to allow Kalyan Chakravarti sir to.
sir, I'm not the host anymore now because the rights have come to Kalyan sir now. He is the host.
I
Yes.
think Kalyan sir, you have to allow the other account also to access.
Yeah.
So you need not lose your host access. You can make him a co-host.
I had made all of you co-host, but for some reason he was not able to share his screen or something. So he asked me for the host rights. I'll take the host rights back then. No issue.
Yes, please. Thank you.
I'm making everyone co-host now, of the teachers. Just give me a moment, huh?
Kalyan sir, now your video is visible in both.
Yes, sir. But only a host can share the screen. So I wanted.
Okay, understood. Okay,
Yeah.
My bad. So now I think you have this permission, sir. Cool. Sir, are you able to share your screen now? Okay, awesome.
So good evening, everyone. Thank you for joining the session. Now here is the question where in the question it has been asked that there is a infinite long current carrying wire which is placed along the z-axis of this coordinate system and it is carrying current I. Now let us say this is x-axis and this is y-axis. 2 points have been mentioned here. The one point A is minus root 3a comma a, whereas the other point is a comma a. There is a straight line joining these 2 points. Let us consider these 2 points as points A and point B. Now you are supposed to calculate what is the line integral of B through this path. Let us calculate it from point B to point A. Now this was the question that is posed in your JEE Advance paper 1. I hope most of you can recollect this question and I wish most of you have solved this correctly. Now let us proceed. Now here, the identification that this path can be broken down into 2 parts and each part is a part of a regular polygon makes this question much simpler. That is, you can consider that this point as point C. Now you can consider this path CB or BC as a part of a square with origin as its center. Now for that, we can consider a square of side length 2a and at its center, there is an infinite long current carrying wire carrying current I. And you are supposed to find out what is the line integral of magnetic field B. Now here we can see the magnetic field due to this current carrying wire at these points would be somewhere in this direction. This magnetic field is perpendicular to the line joining that point with that current carrying wire. Now, this line integral of B throughout this square, you know, by Ampere's law, it will be equals to mu naught times of I. And also, now you can see that this line integral will take out same numbers through this path and through this path. Likewise, if you divide this edge length into two equal parts, this and this, by symmetry, the line integral along these two lines or these two segments of this edge will be same. And thus, we can say that by similar logic, the line integral through these parts are also same. And thus, if you want to find the magnetic field's line integral from point B to point C, you can see that comes out to be equals to 1/8 times of mu naught I, which is the line integral throughout this square length. Likewise, you can see this line, this point, that is the remaining segment, AC segment, you can recognize that as a part of an equilateral triangle, which I'm going to draw it here. Now here we have an equilateral triangle of side length 2√3 times of A. Then we can see its distance from this current carrying wire. The perpendicular distance from this current carrying wire will become A, and that is what is being given in the question. And then this length is nothing but half of the side length, which is √3A. Now again by symmetry, we can see that the line integral through this part and the line integral through this part will be same. And the line integral through this half, the line integral through this half is also same. Likewise, we can see that line integral through this half and this half will also be same. So we know that the line integral throughout this equilateral triangular edges, when you move in anti-clockwise direction, will be equals to this closed integral will be equals to mu naught times of I. But by symmetry, all this path length can be divided into 6 equal parts. So magnetic field line integral through any one path will be equals to mu naught I divided by 6. Now, if you want to find the total line integral from B to C and C to A, it is nothing but the sum of the line integral from B to C plus C to A, which is mu naught I divided by 8 plus mu naught I divided by 6, which is equals to 7/24 times of mu naught I is the line integral when you move from point B to point A. But we are not very sure that the line integral, it is being asked from B to A or A to B. Assuming that it is asked from B to A, it comes out to be equals to mu naught I into 7/24 times. If it was the otherwise, that is the line integral has been asked from A to B, then it comes out to be the negative of 7/24 times of mu naught I. And I wish all the students who are present here are able to get the same answer and correct answer and marked it correctly in the examination. So we'll meet in the other question. Thank you, Mr. Ashish ji.
Thank you, Kalyan sir. Thank you for this explanation of the answer. I request the students to share more and more questions. Yeah, sir, thank you. You can, if there is anything else, you can discuss. Otherwise, we can unshare the screen. Thank you, sir. Okay, so yeah, I think some of the students might be having some difficulty in logging into the session. Whosoever is joining us from YouTube, I'll share my screen again and share how to log into the webinar. Just give me a moment and share my screen. Correct. So you can see here, when you click one of these links over here, let's say you click physics or chemistry, it will lead you to, like with chemistry, it will lead you to a page like this. Here you have to share your name, first name as well as the last name, your email address and phone number, and then register. Even if you do not own a Zoom account, even then you can attend this webinar session. It is just that we want to be in touch with you, as well as Zoom does not allow students to, like everyone to just attend any session without any proper documentation or information. So please write your names, your email address, phone number, and then click register. You will be able to join the live session. Okay. Now I'll stop sharing the screen. Cool. I'm just letting a few of the faculties inside as well. Himanshu ji. Okay. Just give me a moment. Huh? Cool. So let's take some questions from the students. Let's invite some students. Would anybody like to share how has been their experience of today's paper? Anyone who would like to share can raise their hand. I hope I'm audible. Any of the students who would like to share their experience of today, they can raise their hand. I'll give them the privilege I will allow them to talk. They can come on to this live session and then they can share their experience of today. Okay, let's wait for the students to reply. I myself went through one of the articles that was shared in India today. I think after the first paper, they were giving a basic idea about as to what kind of paper was there in today's first session. So there were 51 questions in that session, and 17 basically each, 60 marks in that, and there were 4 sections. So I'll just share that article with you as well. Yeah, so I hope my screen is visible. Yeah, so you can see that there are total of 180 marks, 51 questions, 17 questions in each subject, and 60 marks each. There were 4 sections, section 1, section 2, section 3, and section 4. 12 marks each. 12 marks for the first 2 sections, 24 for the second or third, and 12 marks for the last section. In that, there were only 1 option correct, and then there were 1 and more options correct. Then there was non-negative integer type and the match list type. These were the 4 types of questions that came. So about the chemistry, it was from easy to moderate. For physics, it was from moderate to difficult. But surprisingly, mathematics was comparatively easier as compared to the previous years that I came to hear. During my days when I was preparing and when I cleared the IITJEE, I cleared that exam in 2006. During that time, everyone used to be very afraid of mathematics exam. It used to be so tough. I think with time the pattern has actually changed now. Anybody else would like to share their experience of today, or Or anything about the overall difficulty of the paper? What subject or section was the most challenging for you? Any student would like to share that? Good. No issue. I'm sharing these links with you on the chat so that you can share it with your friends. So to join, I'm sharing it on the chat. Yeah, there is Zoom link for physics, chemistry, maths, and then YouTube links as well. These YouTube links are for those students who are preparing for IIT JEE 2025 or 2026 and even beyond. So it is a very great opportunity for the students to see what the level of question that comes, what kind of questions that come, and what would be a best way to solve these questions. Okay, so it's a great opportunity. Please share this opportunity with everyone who you know who is preparing for IIT JEE. Yeah. Okay, and apart from that, there are a few contact numbers that I'm sharing now. These contact numbers are the contact numbers of the centers: Coimbatore, Kochi, Chennai, and also All India helpline number. The inquiry timings are from 10 a.m. to 7 p.m. Okay. Now, the if anybody has a question regarding regarding the uh, you know admissions or the admission process, I request them to share that query on these numbers, call these numbers during these times, and get your queries answered. Any query regarding this will not be shared or discussed on this forum. I again request anybody has any of the participants, if they have any uh, query to share with us on this platform, on this live session, they can raise their hand, not their literal hand, but the raise hand. They can use the raise hand option on Zoom call to let me know that they would like to contribute to this call. I'll give them the opportunity to speak. Please raise your hands. Okay. Cool. Now, yeah. Cool. Okay. You know, the for the perusal of the students who are going to appear for this exam and who have not sat for the exam, I'll share the analysis that we have done for the last 10 years, and I'll share my screen to share that analysis with all of you. Just give me a moment. Yep. So I hope my screen is visible to everyone. Yeah. So you can see that there's a list of all the IITs over here. This year, IIT Madras is organizing conducting the IIT JEE exam, and you can see that there are different time zones, different geographic zones based on the 7 previous IITs. The older IITs used to be one was IIT Kanpur, IIT Delhi, IIT Bombay, IIT Kharagpur, IIT Madras, right? These were the 5 IITs. After that, IIT Roorkee and IIT Guwahati also joined in. Okay. Yeah. And you can see the number of seats that are available in all of these institutes for UGC, undergraduate students for BTech. Okay. In chat, Ash sir, what is shared above is only among hosts and panelists. It will not reach attendees. Will it not reach the attendees? Okay, just give me a moment. I need to confirm a bit. I think there is some issue. I'll just clear that issue and get back. Is the screen visible to the attendees as well? If it is not visible, please raise your hand. Or is only my voice audible to you? I mean, the video and the audio, is that the only thing that is getting through to all of you, all the attendees, or are you able to see my screen as well? Screen might be visible to the panelists, but to the attendees, I'm not sure, as you said. To all the attendees. Okay, so I'll continue with this analysis that we are sharing with the students. I hope the screen is visible again to everyone. So these are the number of seats which are available. The more important thing in this is that the number of questions or the percentage of questions that you need to solve. So this is the analysis that I wanted to share with you. So you can see that for getting admission, there are like 17,000 plus seats available in IIT, in different 23 IITs. To be able to get a rank around 10,000, these are the percentage of marks that you need to have out of total. Okay, so this somewhere, if we take the average of this comes out to be somewhere around 35%, 30 to 35%. Just which, like in general, the marks which are scored in school, 33% is the bare passing marks. And we are talking about just scoring those passing marks in IIT JEE Advance to get at least somewhere around 10,000 as your all India rank, right? So then again, if you want for 5,000, this number, this average somewhere would be around 40 to 43%. Okay, so the point I'm trying to make is that it is not difficult to target these numbers. Okay, and to get these numbers, the strategy can be that you need to have clear idea as to what kind of questions are very difficult or difficult, and what are easy and moderate type of questions. If you're able to develop that skill, you will be able to mark them, and then you will be able to solve them correctly. If you're able to do that, then this is not that difficult a task. I'll just check again if there are any other students. I'll just unshare my screen again. Just give me a moment. Cool. Any of the attendees would like to share their experience of today? Any challenging questions that they faced? If anyone of you would like to share, please raise your hand, please, or use the raise hand option on the chat. Okay. I think I've let Tanmay sir in as a panelist. Yeah. Cool. So Kalyan sir. Okay. Cool. I'm sharing my screen again just to continue with the discussion. Now, as I said, like even for 5,000 rank, the percentage of marks that you need is not very high. It's around 42 to 45% on an average. If you look at the last 10 years of the ranks, right? So I'm not saying that IIT JEE is easy to crack. It is not. It is still a very good exam which tests your analytical abilities to a very good extent, and you have to prepare a lot, and you have to get your concepts clear. You have to learn a lot to be able to have a crack at this exam and be successful at it. But the if you keep your strategy very firm and you follow that strategy of learning how to pick up the easy questions and then do them correctly and maintain that accuracy percentage, you will be able to do that pretty well. Yeah, so these are some of the format of questions that we usually get. You see here, you can see that. Just give me a moment. Huh? Yeah, so you can see that there are usually numerical type of question, multiple correct, matrix match type, or the integer type. These kind of questions that are coming. Mostly. So marks per question. These are were some of the very basic things. But what is more important is the kind of questions which are coming in each type. You can see that 40% around on an average come the numerical type, which is the one option correct, and then around 20% or 25% questions come for multiple correct choice questions, and then the matrix match type has almost just 10% of the overall marks. in all of these three examinations of physics, chemistry, and mathematics, right? Okay, the single correct choice is around 20%, not 40%. It is the numerical type, and then the comprehension type. Very rarely they come, but when they come, it is like 5 to 10% of the total marks, right? See, question JEE 2022 advanced paper analysis says these are the the distribution of easy and moderate questions. So in physics, you can see that paper one, there were around 11 plus 4, 15 questions which were easy and moderate only. Okay, and same with chemistry. There were around 14 questions out of 18 which were considerably easier or moderately easier. Okay, same with mathematics. So if we are able to develop that ability to mark these questions and solve them correctly, or isolate these questions and solve them correctly, then I think the strategy will work for you and you will be able to score better marks. In fact, if we look at the last 5 years, around 74% of these, if you're able to score that many marks, you will be able to be in top 100. So of course that is a tentative the marks or the percentage of marks, but this gives you a ballpark figure, definitely, right? Let's look at cool. Now, the distribution of questions from 11th and 12th standard is pretty much the same every year. Sometimes it goes in the favor of 11th standard, sometimes it goes in the favor of 12th standard. But overall, somewhere, if we see that it is 50-50 only. So if somebody says that you need to concentrate on a particular class, I think that's not a right strategy to go about it. So here you can see that in chemistry, in the last 5 years, major chunk has come from 12th standard, but in 2020 it was from 11th standard. So you cannot predict this pattern. So better strategy would be to concentrate all of on both classes. So for mathematics, you can see that the class 11, class 12, same kind of a distribution is there. Okay. Now, if we talk about combined, like all the 3 subjects, right? If we go for that, you can see that 50-50% is mostly the coverage. Yeah, 50-50 is mostly the coverage for each of the classes, 11th standard or 12th standard. So that is what our analysis also says, that it is 50-50% only. Okay. Now, if we look at physics, if we want to do that analysis, see, in 2023, 50% of the questions came from mechanics, 18% came from electromagnetism, 12% came in thermodynamics, 9% optics, and then 9% physics. Now you can see that mostly modern physics has remained somewhere around 10% only. Thermodynamics is also around 11 to 12 or 13% at max. Okay, so electromagnetism sometimes goes up, sometimes goes down, but these 2 things remain almost the same. For optics, it's also a little up and down only. Similarly, you can see chemistry. Most of the times, it's either the physical chemistry or organic chemistry. But if you take physical chemistry, is usually the more prominent one in this, and then organic chemistry, and then inorganic chemistry. One of the things that I read on that article that I showed you earlier in India Today was that the inorganic which came, the questions in inorganic which came in paper 1, they were mostly from NCERT only. They were not from any. They were not from any other. Just a second. They were not from any other source. So for inorganic, the best strategy is basically to go through everything in NCERT and then prepare for that. Okay, and you need to have that by heart. With mathematics, you can see for algebra, mostly the questions are coming from algebra. Around 35 to 40% are from that. Calculus is again 25 to 30%. So around 60-65% is basically covered with these. So I'm not saying that you should not venture into other parts of mathematics, but you can keep some parts very strong, that you are able to solve question, even very difficult questions in that particular uh, part of mathematics. Okay, so here you can see basic percentages. Now for physics, if you go for the chapter wise distribution of marks, you can see heat and thermodynamics for the last 5 years, you can see that it is 15.75% on an average. So heat and thermodynamics, I remember my own preparation. Heat and thermodynamics was I actually liked it a lot because it was there in chemistry as well as in physics. So it was like, if we have concepts clear for in one of those, there are obviously some differences, but if we are clear about the concepts of thermodynamics, heat and thermodynamics in one subject, then it will help us in the other subject as well. So it is, in my opinion, it was very scoring for me. I used to be able to do these questions quite well. Okay, so heat and thermodynamics is one of the areas which you can definitely look into. Of course, all these areas, this kinematics, laws of motion, work, power, energy, rotational motion, fluid dynamics, gravitation, SHM, and elasticity, and of course surface tension and viscosity, all these basically are parts of mechanics. So even if the percentages are lower here, overall percentage will be quite higher as compared to 15.75, which is heat and thermodynamics. But yeah, if you want to look at a particular chapter which is you know which is in particular uh, kind of from which a lot of questions come, then I think heat and thermodynamics is the one. Okay, so you must definitely concentrate on heat and thermodynamics in your preparation. Okay. Now I just want to see how many participants are there. Aditya Pandey, Alta BS. Would any one of the participants like to contribute or ask me any question regarding the preparation or today's paper that they sat for? Jagat Rakshan ji, Sharanya ji, would any one of you like to contribute to this session? If you do like to contribute, please raise your hand so that I will give you the opportunity to speak. I'm not able to see anybody raising their hands. Okay, so sure, Shankaran, confirm your decision. Okay. Anyway, so let us continue with this. Yeah. So to be able to cover, let's say, around 35 to 40%, these two, heat and thermodynamics and mechanics, would be enough. But then electrostatics and magnetism, optics, modern physics was again quite I used to find it a lot easier. So 9 to 10% of your marks come from there. So you can also add that into your kitty as to percentage. I think a few more questions are getting ready. Just okay. As soon as they are ready, I'll let one of the faculties to share the question. I request the faculty to let me know if they're ready with the questions. Okay. On this chat only, I think it would be better if somebody lets me know on this chat only. Cool. Yeah. And these are the last 10 years percentages. You can see again here, heat and thermodynamics is still the amongst the highest percentage. And see, almost 11% for modern physics. You see? Just give me a moment. Huh? Yeah, I think this will be a better way. Yeah, you see here 13.31 percentages. I think not pointer, pen. See here, here. But if you look at mechanics, kinematics, and everything, this comes out to be somewhere around 25 to 30%. See, even if these three you have done very, very well, okay, even then it reaches around 40%. See, you have to maintain accuracy. I'll share an anecdote from my own preparation. In 2006, when I was sitting for the exam of IIT JEE, there used to be something called AIEEE, All India Engineering Entrance Examination. So it was kind of like um, the examination for NITs and other colleges or other regional colleges. So I remember I went for that paper in 2006, and after completing the paper, okay, there was some glitch, of course, about me not being able to mark the questions, the answer of those questions which I had already solved. So I'll share that some other time. But what I want to share is about the accuracy. So that paper was for 540 marks, which is 180 marks for each subject. 180 for physics, 180 for chemistry, 180 for mathematics. I remember that the time left for mathematics was very less. I think it was less than an hour because it was a 3 hour question paper. For that time, for less than for that 1 hour, for that less than 1 hour that I did the mathematics paper, I was able to solve questions which were worth 90 marks only. And guess what? When I checked my answers or when I got the result, at that time they used to give you individual marks as well. I got 90 out of 90 in mathematics. I had 100% accuracy, right? My rank was, I think, somewhere around 3,000 all of India. So what I'm trying to say again is if you are able to maintain your accuracy, even then you will be able to score well because not attempting the whole question paper and then getting them incorrect is a great strategy. But even if you attempt half the number of questions or the number of questions which are equivalent to half the number of marks, and you do them correctly, 100% correctly, you will always be able to do well. So yeah, that was one of the personal anecdotes that I can recall. Also, one of the things which helped me in improving this accuracy was when I used to do my test analysis. So whenever I used to sit for a test, my teachers, they were also from FIITJEE. They taught me how to analyze the test and analyze my mistakes and then group them into different ways. Uh, I think it would be better if I show you that. Just give me a moment. Keep your ink annotation. Just give me a moment. I think it should be somewhere here. Just give me a moment. I think it is, yeah. So this is the test analysis. These are the kind of mistakes a person usually makes. So I also used to make such kind of mistakes. I used to make sometimes the calculation mistakes, and as soon as I started catching my calculation mistakes, I got aware that I'm making those mistakes. I used to assume that I'm some kind of a superhuman that who is not going to make any of these mistakes, but I did used to make those mistakes, and I made sure that I did not. And I started, like, whenever I used to do a question, I used to doubly check, triply check that my there is no calculation mistake. And there came a time when in any of the exams that I gave, there was no calculation mistake at all. Second of the things which I was made aware through this was through this analysis was that sometimes I used to misinterpret the question or misread the question, or I was not really reading the question properly or completely. So just give me a moment. I think Ajay Bhan. Would anybody like to participate in the, in this live session? Would they like to share their experience for today's exam? I think there are a few more students who have joined today. Now, would anybody like to join this session? If you like to join, please use the raise hand option, and whosoever does, I'll give them a chance to speak on the live session. Anyone? Okay. Yeah. So coming back to this, reading this particular question, or the reading questions incorrectly, or uh, you know not completely, this was something which was also happening. So when I analyzed why a particular question was wrong, why did I not do it, or why did I do it but incorrectly, so I also realized that I was not reading the question properly, because you are always under the pressure that you have to do all the questions, you have to complete the questions. Okay. And nowadays it is even more. I think students are getting almost 100% marks in their board examinations. That means they are attempting complete paper. During my time, I think some of the question papers were not completely attempted. So this pressure was there to attempt the complete paper. So in that pressure, sometimes you used to forget uh, forget reading the question paper or the question properly. So that also led me to answer the question incorrectly. Like when they would ask which of them is not the answer, and I would read it as which of them is an answer, or which of them is the correct answer. So I would always mark that with the correct answer. So that used to happen. So when I got aware of this fact that I was making these kind of mistakes, I started reading the question more carefully, and thereby I was able to avoid such mistakes. Okay. So when I was able to do that, then uh, I could see that with the same preparation, with the same amount of questions done, with the same amount of conceptual clarity, I was able to score more. Okay. Uh, you know, and similar kind of questions I used to find that these kind of mistakes I was making. Okay. So I again invite you all to do those that test analysis, because even test analysis, that is that tool which will help you score uh, marks, with more marks, even with the same amount of preparation. Okay. So if you prepared really well, and you have not done the test analysis of your tests so far, the best strategy would be to go and do that, so as to know where you're making the mistakes. And if you're able to avoid that, you will be able to add more marks to your kitty. So just imagine, and if scoring more marks definitely leads to better ranks, but we'll just do an analysis or a simple calculation. See, if you do one question correctly, you get 4 marks. But if you do one question incorrectly, you lose 1 mark. That means the opportunity of marks that you lost is not just one, that you lost 5 marks, right? 4 marks for being correct, but 1 mark for losing 1 mark for being incorrect. So total you have lost 5 marks, right? So one question is actually equivalent to 5 marks, let's say. And if you're able to do just 4 or if you're able to avoid uh, doing incorrect questions, just 4 of them, right? So that means 20 marks you will be able to score more. Now, just let's say on an average, you have 360 marks in total in the examination, and around 100 is the cutoff, right? And top rankers would be around 350. So there is a gap of 250 marks from the first ranker to the last rank, right? And let's assume for the sake of calculation that there are 20,000 ranks or 20,000 seats in IIT JEE. So 20,000 divided by 250 marks. So per mark, 80 ranks are there. By just a difference of 1 mark, you will be able to score 80 ranks higher, right? So just imagine how many ranks you will go up by if you avoid just 4 avoid making 4 mistakes. Okay, that means you are able to score correctly in these 4 questions. You are going to be able to avoid 5 of these marks per question. That means 20 marks, and 20 marks translates into number of ranks or the change in rank to 1600. So give or take, it is between 1500 to 2000 ranks. That is huge. So improving upon your mistakes, or rather not committing any mistakes, is the key. So yeah, so I used to be able to do that. I just check if there are I'll just ask the people, are we ready with some more answers? Just give me a moment. Okay, Pawan sir, are there more questions which we can discuss now? Okay, so I invite Professor Saurav Mandal to discuss the second question. Welcome to the session, sir. Professor Saurav Mandal is a veteran in is a veteran teacher in physics. He has had more than 18 years of experience in teaching, and he has been with FIITJEE for a long time. Welcome to the session, sir.
Thank you, sir. Am I audible?
Yeah, you are audible. If sir is not audible to the attendees, please raise your hands. In case nobody is raising hands, I will assume that everybody is able to hear, sir. So, sir, nobody has raised any hands. So
Okay.
please go ahead, sir.
So first, let us see the question. The question says that there is a metal target.
Your screen is not visible.
Oh, sorry. 1 minute, sir.
No, sir. No, sir.
Uh,
I think you are guest only. Okay, nee. Your co-host.
did I go? Zoom only. I have to share the screen. Okay, can I share?
Please share, sir. Please share your screen. Yeah, the screen is visible, sir.
Now is the screen visible?
Yeah, it's perfectly visible.
So there is a metal target. So students, let us see, this question is from X-rays. Every year almost, questions from X-rays do come. And they come only in the same pattern on K alpha line, and the trend remains almost the same this year. So we find that there is a metal target Z equal to 46. It's 46. It is bombarded. It is bombarded with high energy electrons. Okay. With high energy electrons. Right. And there are K alpha line is emitted. And they are saying that ratio of K alpha line to that of the cutoff wavelength, ratio of K alpha, that is wavelength of lambda of K alpha to that of cutoff wavelength, is R equal to 2. Right. So we are saying that the ratio is defined as R. In this case, it is 2. Right. And if the same beam is used to bombard, same beam is used to bombard another target, Z equal to 41, then what will be R? Then find R. Okay. So let us see, first of all, what are the characteristic wavelength that is emitted? We know that 1 by lambda is equal to R into Z minus B into 1 by N1 square minus 1 by N2 square. For K alpha, what is K alpha? K alpha means it is a transition from the second to the first. So for K alpha, B is 1, K shell, it comes to the K shell. So the screening constant B is 1, and N1 is 1 and N2 is 2. So what do I get from here? 1 by lambda, I write it as K, is equal to R into Z minus 1, the whole square, into 1 minus 1 by 4. Okay. So this becomes 3 by 4 R into Z minus 1, the whole square. This is 1 by lambda K. Right. Or what is lambda K in that case? I can write 4 by 3 R Z minus 1, the whole square. Right. Let us now see what is the cutoff. Cutoff means if the whole energy which is coming, the photon, right, it gives the whole energy at one go and electrons come out. So we can say that if the energy is EV, that emits a photon, hc by lambda cutoff. I write C. So or lambda C is equal to hc by EV. Now they are saying that R is the ratio of lambda K by lambda C, right? So what will you get? Here I'll get 4 by 3R Z minus 1, the whole square, divided by lambda C, we'll get EV by HC. Or in other words, if I see 4, R, E, V, AC, all are constant, because in the second case also, we are using the same beam, which means the energy is same, right? So R can be written proportional to 1 by Z minus 1 the whole square, correct? Okay. So if I write this as R2 by R1 would become equal to Z1 minus 1 the whole square by Z2 minus 1 the whole square. So R2, what is to be found out? Z1 is 46. Given, it is given as 46. So it is 46 minus 1 the whole square by 40, sorry, what is it given? 41, right?
Sir,
41
can we go back
1.
to the question so as to show the
Yeah. See, the question says it is Z equal to 41.
okay.
And the first case, Z equal to 46. Okay. So that into R1 was given as 2. So if I solve it, it would be 45 by 40, the whole square into 2. So if I cut it, this will be 9, this would be 8. So 9 into 9, that is 81 by 64 into 2. If I solve this, it comes to be 2.5. So that's the answer, right?
Does anybody have any doubt on this? If they would like to ask any question regarding this particular question, please raise your hands.
I will show you the solution once again.
Sure, sir. Please go ahead.
So the question is like, there is a metal target. High energy electron beam is falling onto it. Obviously, as you know, that when high energy electrons fall on a heavy metal target, it emits X-rays. Why does it do? You have heard about the process of Bremsstrahlung, isn't it? That is, as the electron comes, the electrons will undergo multiple collisions and it will lose the energies, right? There are two types, the continuous X-rays and the characteristic X-rays. So in the characteristic X-rays, what happens? The electrons transit from one level to another. So that K level, L, M, so such levels are there. So transition happens. So when there is a transition from L to K, it's K alpha. So we find that here they have given that K alpha transition, the wavelength that is emitted, and for the cutoff wavelength, that is the maximum energy, right? And their ratio is given, isn't it? So we find that if I use it, I will get the ratio which is called named as R in this case. Okay, we find that R is inversely proportional to Z minus 1 square, and both the Z values are given to you, and therefore easily we can find out the value of R. So it was a simple question. I would put it as easy. If you know the formula, you can just do it. If you have any question, you can ask.
Okay, sir, I think so. Thank you for such a detailed explanation of this question, sir. I think my memories have come back of this particular chapter. So thank you, sir.
Right. Okay.
So I'll invite Ram Subramanian, sir, to discuss the next question. Thank you, Saurabh, sir.
Thank you. Thank you, Ashish.
T cube.
So you can unshare your screen.
Yeah, I'm trying to do that.
Gamma is equal to
Yeah.
Okay. Welcome, Professor Ramasubramanian. Professor Ramasubramanian has more than 15 years of experience in teaching physics, and his favorite topic is optics. although he loves physics from one end to the other. Yeah, and he has been able to like work with students and send them to the top IITs in India, and his students have gone on to do a lot more in the field of engineering thereafter their BTech. So welcome, Ramasubramanian sir. How are you?
Yeah, hi, I'm fine. Thank you for those words of welcome.
Got it,
So,
sir.
yeah,
Yeah.
without much
carry
ado,
on.
let us
Start.
get on directly to the question. You know, now we are going to discuss mechanics question, specifically involving a lot of calculus. You can see
If you
lot
can
of.
share your screen as well.
Yeah,
because-
sure. Let me do that. Give me 2 minutes. I don't think screen sharing is coming. So be coming as a document sharing. Let me recheck it. There you go. I hope my screen is visible to everyone. Can everybody confirm whether they are able to see what's on my screen?
Any question? Any problem you are facing, sir?
Are you able to view my screen?
Yes, I'm able. Yeah, I'm able to see your screen. Double click to enter full screen mode. That's what it is showing, but it is all black.
Was it? That's exactly what I'm seeing as well. Let me recheck it.
Sure, sure. Please take your time, sir.
No matter how many times I share, I guess it's showing as a black screen.
Okay. So,
Like that, try
shall
something
we invite
else.
someone else till you're able to? If someone else
Please
is
give me
ready.
2 minutes.
Okay, sure.
I'll get it ready.
more and more students are joining us now. I think there are quite a few students who are there on YouTube who have joined us through YouTube. I invite them to. Okay,
finally, I think it's available.
Just want to continue this. I invite all the YouTube people who are joining us through YouTube. I invite you to join from this webinar and ask your questions live. Please go ahead, sir.
Yeah, I hope the question is visible now.
Yeah, it is. It's clearly visible.
Given that block of mass 5 kg moves along x-axis direction and subject to a force which is given by the expression minus 20x plus 10 meter. The particle is at rest at t equal to 0 and x equal to 1 meter. What is the position?
A little lower. Can you?
Yeah. It's asked what is the position and momentum of the block at t equal to pi by 4 seconds. There are some options given for this as well, but let us not look at it for a moment. Let's first see how to solve this. This is on the initial glance, it may look like it's a modified form of an SHM question. And yes, that's how we need to view it as. The moment we see that the force is given by this expression, the first thing that we can do is write down that its acceleration will be F by m, which should be minus 4x plus 2, since it is given that mass of the body is 5 kg meters per second. Now, had this been just a equal to minus 4x, everyone knows that you can conclude it's an SHM with omega square being 4, therefore omega equal to 2. But what to do if it is having a plus 2 term? This is, if you recall your basics, SHM about a shifted mean position. Therefore, you need to take what the mean position is. The mean position you can calculate by taking where the acceleration is. And from this, we can see that the acceleration becomes 0 at x equal to 0.5, which means the displacement, you can first write it as a general expression. X is equal to a sine omega, which we can see from the expression omega square being 4, omega being 2. So a sine 2t plus initial phase plus the shifted mean position. So this is how we need to get started with this system. We need to write it as the equation of an SHM about shifted. After this, finding A and delta can be done based on the condition. We can see that at t equal to 0, x is given to be 1 meter. And at t equal to 0, starting from this. If at t equal to 0, x is 1 meter, it is very, very clear that if it is starting from this there and it is beyond the 0.5, that should be the positive amplitude of the body, which means that the amplitude is 1 meter from the mean position of 0.5. Which means A is equal to 0.5, we can see. And after that, it is also clear that since it is starting from positive amplitude, therefore its initial phase should be pi by 2. So therefore, when you write A sine 2t plus pi by 2, the function becomes cos. Therefore, we can write that x is equal to 0.5 cos 2t plus 0.5 is the expression for position of the body at any time t seconds. And to get the velocity, we simply need to differentiate, which we can do by getting v is equal to minus 2 times 0.5 sine. And the momentum is, of course, mass times velocity. So in this, we can see that according to this equation, at t equal to pi by 4, we get cos pi by 2, which is 0, which means x is equal to 0.5 at t equal to pi. And when we find velocity at that time, we get sine pi by 2, which is 1. Therefore, the velocity is minus, which makes the momentum minus 5 kg meters per second. So these are the two things which have been asked. I hope that the equations are clear. If you have any confusions, if there is something that you don't follow, you can feel free to ask. For example, if you are not sure how from here I was able to conclude that the equation for x is 0.5 cos 2t. If anybody has such a confusion, I request you to please feel free to ask.
Does anybody have any doubt on the solution of the question? If there is any doubt, please raise your hands and I will give you a chance to speak and ask your question. So there doesn't seem to be anyone who seems to be having a doubt in this. So I think it is pretty clear for them. So you can go ahead, sir.
Fine then. Then let's conclude this session. Meet you in another question.
Okay. Thank you very much, sir, for the detailed explanation. So I'm calling Saurabh, sir, Professor Saurabh Mandal. Saurabh, sir, if you are ready with your with the question. Saurabh, sir, are you ready with your question?
Ashish sir, Raghuram sir is ready. You can call Raghuram sir.
Okay. Okay, sir. Raghuram sir, if you're ready with the question, please come. You have the rights.
Just a minute, sir. Just a minute, sir.
No issue, sir. So you're not connected with other.
Yes, sir. I'll just get connected to that one. And meanwhile, once we ask, we'll ask and see if Kalyan sir is available.
Okay, I think your Himanshu sir is connecting. Okay, I think there is some issue which Raghuram sir is trying to solve. I think we can put Saurabh sir online to come up with share his solution with the audience. Saurabh sir, the floor is yours. Please come and.
Hello.
Yeah.
Can you hear me?
Yeah, you're audible, sir.
Right.
So we'll discuss the vector problem. The question, whatever the ask of the groups. The question says that OP
Ashish,
is a vector.
can you give me a few minutes?
Okay, okay.
I'm just having a problem over here in sharing. Just few minutes.
Plus
No issue, sir.
J cap plus.
Let's see if Kalyan sir is ready. I think we can then put him. Kalyan sir, if you are ready with your solution, please come and take forward the session.
Yes, thank you.
Yeah. Okay, sir.
So welcome back, students. I hope most of you are looking at these questions and checking whether you have done it well or not. But in spite of that, in spite of the result or the questions that have been correct or incorrect till now, you have done a very good amount of work till now. So enjoy the remaining days, right? So one more question has been shared from one of you. And this question is from units or measurements. And I hope and I know that most of you have solved this correctly. Now let us see what that question is. It's a very simple question. It is from your errors. Now this question says that there is a cone and this cone is, the cone's dimensions is being measured by a measuring instrument whose least count is given as 2 millimeters. Now, it is measured the radius of this cone as 10 centimeter and the height of this cone is measured as 20 centimeters. If so, if you are going to calculate what is the volume of this cone by using these dimensions, what would or how much error would have crept in it because of the errors that would have crept in measuring radius and height. Now, let us see what is the volume of this cone in terms of radius and height. It is 1/3 pi r square h. And by dimensions, you know that the fractional errors will add up in this way. If there is a factor, if there is a variable z, which depends upon x and y as this function, z is equals to x power a plus x power a times y power b, then the fractional error that is measured in z, that is delta z divided by z, will be equals to a times of delta x divided by x plus b times of delta y divided by y, where delta x and delta y are positive errors that are measured while measuring x and y. Now you can see here the change in volume, that is the error that is measured in this volume in calculating volume. 1 minute. I think we have to start it from the start. I'll just write down the things we have noted till now. The least count of the measuring instrument is given as 2 millimeters, whereas the radius of the cone that is being measured by this measuring instrument is given as 10 centimeter, and the height of the cone that is measured is given as 20 centimeters. We are supposed to calculate what is the fractional error or the percentage error that would have crept in calculating the volume. You know that the volume of this cone is 1/3 pi r square h, and thus the fractional error in volume delta v by v is twice delta r by r plus delta H by H. The power of R is 2 and power of H is 1. I hope you all have observed that. Now, in this case, the change or the error in R, the maximum amount of error in R is the least count of that measuring instrument, which is given as 2 millimeters, whereas the radius of this cone is measured as 10 centimeter or 100 millimeters. Plus, likewise, the error that we have crept in measuring H will also be equal to the least count of the measuring instrument, which is 2 millimeters divided by the height that would have been that has been measured by this, which is 20 centimeter or 200 millimeters. So this turns out to be equal to 0.04 plus this one will be 0.01. So the fractional error is 0.05. The percentage error in calculating volume, delta V by V times 100 will be equals to 5%. I hope and I know most of you have done it correctly. It's a simple question. And there should not be any error in making calculations. Right? Let's move on to the next question. Over to Mr. Ashish sir.
Thank you very much, sir. Thank you for such a detailed explanation. This was one of the areas which, during our time we not used to put so much effort into. But I think units and dimension is a very good topic to concentrate upon. I think there is no one, like I invite students, if they have any doubt on this, they can raise their hands, and I'm inviting this students who are there in this webinar, this live discussion. If anybody is there on YouTube, they can come to this live session and they can share their doubts over here. They can ask their questions over here. So again, and all the participants, all the attendees of this session, I request you, if you have any doubt regarding the previous question, you can share it here. You can raise your hand. I will invite you to speak. And then, okay, one of the panelists has raised their hand. Saurav sir is ready. Okay, so I think we can move on to the next question then.
Can I go ahead,
Yeah, yes, sir.
Ashish?
Sure.
We'll wait, sir. We'll wait, sir.
Kalyan sir, you are also ready, yeah? Kalyan sir, can you please go on mute?
Okay, so we'll take the question. Hello, students, can you hear me?
Sir, MRK, sir, ready, sir.
Yeah, you're audible, sir, and your screen is also visible.
Okay, right. Let me just take out the question. Yeah. So the question is basically, there is a circuit. The circuit is, there is a capacitor. Which has a value of 10 microfarad. This is connected to an inductor. And this too via a key K1. Then there is a resistor here, which goes to a 20-volt battery. And this is connected via key K2. Right, this is a circuit given. Now, it says that these are three different parts of this question. At t equal to 0, K1 is open. Sorry. This is K2 and this is K1. At t equal to 0, K1 is closed and K2 is kept open. And K2 is kept open, right? Okay. So, what is the initial current? What is the initial current?
What is their normal solution?
Okay. So what we know, initial current means when I close it, what will happen? Current will try to flow. But you know what inductor does? It tries to oppose, isn't it? You have studied Lenz's law, isn't it? So LdI by dt is the EMF induced across the ends of an inductor. And you know, if we solve this, this inductance is 25 millihenry, it is given. So we know that the current is I naught V by R 1 minus e power minus RT by L. Okay. So if at t equal to 0, I find the current will become 0. Next, after a long time, why it becomes 0? I can give an alternate. See, at t equal to 0, there is a very high rate of change of current happening, right? So the rate of change of current is maximum, and therefore the opposition provided by the inductor is also maximum, which can be highest equal to the voltage which is applied, and therefore no current flows through the inductor at t equal to 0. When I write after a long time, I is equal to V naught by R, V by R. Here V is given to be 20 volts and R is given to be 5 ohms. This R is 5 ohms given value. So the current after a long time in the circuit is 4 amperes. That is when K1 is closed and K2 is open. Now part C says that if K2 is closed now and K1 opened, then what will be the amplitude of oscillation of the voltage, amplitude of oscillation of voltage across the capacitor. We know that when there is a LC circuit, the energy will oscillate between the L and V. So basically, at the beginning, when K2 is closed, at that time a current I naught is flowing through the inductor. Therefore, the energy stored in the inductor is half L I naught square, right? And when is the maximum amplitude? When the whole energy is converted into the electrostatic form, that is becomes equal to half CV square, right? So in this case, V becomes equal to L I naught square by C. We will put the values. L is given to be 25 millihenry. I naught we know is 4 divided by capacitance is 10 into 10 power minus 10. Minus 6. This is given to be 10 microfarad, right? So if I solve this, 5, 2, 2, 8, 5 is a 40 into 10 power 3 is V square. So V is equal to 200, right? So this would be the amplitude. Okay, is it clear? Anyone have any doubt? All of you understood this?
Yes, sir. I think so far there are no hands raised. So I am assuming that everybody has understood.
Right, sir.
So thank you for the explanation, sir. Even I could understand this.
Thank you. Thank you, Asiji. It's over to you.
Yeah, thank you.
One minute. I'm not able to. I stopped share. Thank you.
Thank you. I think we are ready with the next next question. Yeah, just let me confirm who is ready with the question. Okay, I think Rama Subramanian sir is again ready. I'll give you the co-host. Somehow, your other device is getting dropped, I think, sir. Anyway. Yeah, please, over to you, sir. Please take over. Yeah.
Hello once again, guys. This time we are going to discuss easy topic.
Your voice is breaking a little.
What is perceived as an easy.
Your voice is breaking and the video is slower. Yeah, you are audible, but your videos are a little slow. I think the bandwidth is a little lower. Now it is better, I think. Your movement is also.
Sure.
Yeah, please go ahead.
Yeah,
please.
The topic which I am referring to is, of course, Doppler effect.
Your screen is visible, sir. Please go ahead.
The source emits sound of frequency given, and in the first case, when the source and observer are moving towards one another with a velocity v each, the frequency heard in above case by the observer is given to be 288 Hz. What is the frequency heard in case 2 when the source and observer are away from one another the same velocity? That is the question. See, I'm sure that on seeing the question, initial cursory glance, many of you may feel that in order to solve this, velocity of sound must have been given. So what if that is needed? Should we assume a value? If yes, what value to assume? Some places it's given 340, 330. But once you start solving the question, you realize that it is not needed at all. In fact, this is going to be true for many questions which you may think is hard or confusing. You will not really realize how easy it is unless you start solving this particular question, for example. For Doppler effect, I'm sure
So your voice is not audible. It's breaking. So I think the connection, Wi-Fi connection is not good. It's poor.
different cases and for each of
we're not able to hear you, sir. Can you try again, sir?
Yeah, I think I got disconnected.
Yeah. The internet connection is poor, I think, sir.
I hope. Mhm.
Your voice is
Yeah,
breaking in
I
between.
guess now it's fine. Now is it fine?
Yeah, it's better, I think. Yeah, it's better than before. Yeah, please go ahead, sir. I think you'll have to go from the beginning because the voice got broken somewhere in between.
Okay, fine. Let me recap on what I was telling you. In this question, it will look like velocity of sound may be needed to solve it.
But again, the
So
voice is
how to
breaking.
proceed without knowing that? But let me just check this connection once.
Okay, sir. Sure.
Please let me know whether the voice is better now.
Yeah, it is better. The screen is visible clearly.
Cool. So yeah, just a case of bad network, I guess.
Yeah, I guess. See, if any one of the participants would like to ask any question regarding this question, any
Actually, I
doubts?
haven't started discussing yet.
Yeah. Okay, sir. Let's wait.
Just a moment. I'll have my other device connected as well. Oh yeah, like I was telling you, this may look like it is going to require velocity of sound in order to solve this question. However, only when you start solving, only when you start analyzing what is given and you start writing the equation, you realize that what is given is perfectly sufficient in order to solve the question. And when it comes to Doppler effect, many students, they have this confusion about source moving towards observer, observer moving towards source, which formula to apply when, and all these things. But like with anything else, there is a one simple solution to all this, one formula to rule them all, whatever the case may be, whether towards or away from, you know. And this can be easily remembered as well as operating system, O by S. That is, when it comes to any apparent frequency heard by the observer, it is simply actual frequency times velocity of sound plus or minus velocity of observer by velocity of sound minus or plus velocity of source. The top sign in both numerator and denominator is for when they are moving towards, and the bottom sign is for when they are moving away from. So in the given case, we can see that in case one, both are moving towards. So we can write the earth frequency 288 should be equal to 240 times velocity of sound c plus v naught, which is v, divided by velocity of sound minus velocity of source, which is again given. And the frequency f, which they have asked, is simply the other way around, when they are moving away from it. So we can write that as c minus v by c plus v. The ratio in the second term is simply the reciprocal of the ratio of the first equation. According to the first equation, c plus v by c minus v should be 288 by 240. So that means according to the first equation, c minus v by c plus v should be 240 by 2. And this value can be straightforward substituted over, which will give us that the frequency we are wishing to find is simply 240 times 240 by 2. So remember that for all Doppler effect problems, the single expression to remember is plus or minus VO by plus or minus X. We use the top sign, that is a plus in the numerator and a minus in the denominator when their source and observer are moving towards. And the bottom sign, that is minus in the numerator, plus in the denominator when they are moving away. If you remember this, every Doppler effect problem will become a piece of cake. So now, if there is anything that you would like to ask, you may please do so. From the given equation, it should be clear that the answer should come out to be 200. So right then, if there are no other questions, we can wind up. We'll see you soon in another question.
Thank you for the solution, sir. I don't see anyone raising in their hands, so I think people have understood the explanation. Cool. I think Raghuram sir is ready. Welcome, Raghuram sir. I hope the issue you were facing is over now.
Yes, sir. Yes, sir. Yes, sir.
Okay, great. Great, sir.
Good evening, students. Okay, let us take the next question. So you can see, I am taking a question that the question is from rotation. You can see the screen.
Yeah, it is
so
visible,
we have
sir.
It is visible?
Yeah, it is visible, sir. Please go ahead.
Yes, sir. Yes, sir. So you can see, students, we have got a rod here, which is connected to a string. The other end of the string is attached to a nail kind of, to a nail, let us say. The rod is of length L, as well as the string is also of the length L. Rod's mass is, let's say, it's a uniform rod. If its mass is given to be, let's say, capital M, it is hit, or it is given an impulse J. So you can see here, it is given an impulse J at a distance X from the center of the rod. And it is said that once it is hit, the entire system, the system of rod, the string, entire setup will be exactly going on to the other side like this. Means the string will become like this, the rod also will become like this. If you are giving end A and B like this, B will be reaching here, A will be reaching here. So to this to happen, what should be the distance of X is what is asked to us. So we know that it is involving a plane motion. For any plane motion, we can understand that there will be, to the center of mass of the rod, there will be a linear velocity can be assigned. So I'm assigning a linear velocity to the center of the rod, velocity of center of mass VCM like this. And I will take an angular velocity omega about the center. So the structure is, I will be considering like this. So I just take this way. So this is just after hitting. It starts with the VCM like this, just after hitting, giving impulse. So this distance is X. So as you can see, there is a velocity of center of mass, there is an angular velocity omega, distance X. So if it has to go exactly like this point is supposed to be the instantaneous center of rotation. So instantaneous center of rotation means the net velocity of that point is equal to 0. So I can write clearly, students, that here I can say velocity of center of mass VCM like this. And because of this omega, At this point, I should say L by 2 multiplied by omega because it is at a distance of 3L by 2. I would say that it is 3L by 2 multiplied by omega. So this is 3L by 2 omega. These are the two velocities which are acting in opposite direction, and if only these two are equal and opposite, they get cancelled. We can say that this is instantaneous center of rotation. Only then it will be possible for the entire system to go exactly aligned like this. So we write the first condition that VCM is equal to L by 3 L by 2 multiplied by omega is the first one, which I have written here, equation 1. The next equation, what I'm going to write is, as you know, the conservation of linear momentum along this direction, along the horizontal direction like this. I can write, rather I can say that impulse given J is equal to mass multiplied by the velocity of center of mass. That is equation 2. Then again, I will write angular impulse. Angular impulse is about the center is what I'm writing angular impulse. J multiplied by X is equal to M L square by 12 moment of inertia about the center of mass multiplied by omega. This is equation 3. So I would divide equation 3 by 2. I would write 3 by 2. That implies I can write X is equal to L square by 12 omega by velocity of center of mass, as you understand. J gets cancelled, M cancels. And from equation 1, in this I will be writing, students, VCM place, I would be writing 3L by 2 multiplied by omega. You can see omega gets cancelled, L gets cancelled, and we can write here, this will be L by 18. So X is equal to L by 18. They have asked us to find out X, if it is equal to L by N, find the value of N. So this is a non-zero means integer question is what we have got. Non-negative integer question, which is giving us the answer here, 18. So hope this question is clear to you. A very simple question, as you understand. You might have solved many such type of questions already, and you must have definitely solved in the exam. It is one of the easy questions, rather what we can say, students. Okay, if you have anyone of you have any doubts, please let me know. Tell me. You can raise your hand and you can ask. Anyone have a doubt? Okay, hope this is clear to you all. We'll meet again with the next question. Over to Ashish, sir.
Thank you, sir. Thank you very much, sir. Okay, we can go ahead with the next question. I think Venkat sir is ready. Venkat sir, if you are ready, we can move ahead. Go ahead with the discussion.
Sir.
Yes, sir. Sorry, sir, you are. Yeah.
Navneet sir.
Joining from sources, huh?
Yes, sir. Yes, sir.
Okay, no, sure. Great. I think there is some issue with Venkat sir's device. He's joining from Saurabh sir's device. Please go ahead, sir.
Yes, sir. Yes. I'll share my screen, sir.
Yeah.
Sir, can you see my screen?
Yes, sir, your screen is visible.
Yes, sir. Okay. As for a given question, they said they gave two prisms. Both prisms are kept in vacuum. Light ray enter.
Can you share the question as well?
Yes, sir. Sir. Question. 1 minute, sir. Give me a minute. Can you see the question, sir?
Your question is visible, sir.
Yes,
Please go.
sir. Yes. Okay, given question. Okay, there are two prisms. Okay. Both the prisms are kept in vacuum. Light ray enters P1 prism, that is first one, P1 prism. Let us call this as a P1 prism. Okay, this is P2 prism. They mention that light ray enters P1 at an angle theta such that outgoing ray undergoes minimum deviation. Outgoing ray undergoes minimum deviation in prism P2. Okay, we already know that if it undergoes minimum deviation through prism P2, we have a condition for minimum deviation. Condition for minimum deviation, we know that R1, R2 must be equal to A by 2. R1 plus R2 is equals to, we already know that R1 plus R2 is equals to A. And for minimum deviation condition, we know that angle of incidence through a prism. For example, if we take any prism, equilateral triangle prism, for minimum deviation condition, we know that R1, R1, R2. This is the R1 angle, this is the R2 angle. Okay, R1 must be equal to R2. We also know that condition like R1 plus R2 is equal to A by 2. From this, we can get the angle R2, as I mentioned in the diagram, you can see here. Okay, the angle R2. Here you can see the angle R2. Here R2. R2 must be equal to A by 2. Okay, in this given prism, let us say, first I consider light ray incident in the first prism P1. It makes an angle theta at point P. And the light ray passes through prism P1 and enters through prism P2. Okay, when it makes an angle, okay, entering angle is R1 and emerging angle or emerging angle through P2 is R2. You can see here. Okay, this is the R2. Then we have R2, we directly got the information from the minimum deviation condition through prism P2, which is equals to A by 2. That is 30 degrees. Okay. Then Snell's law at Q. If you apply Snell's law at point Q, you can directly write mu1 sine R1 is equals to mu2 sine R2. Okay, from this mu1 value, we know that, which is root 3 by 2 given in the question. Mu1 value given in the question, root 3 by 2. And mu2 value given in the question, which is root 3. Then if we substitute mu1 value root 3 by 2 sine R1 equals to mu2 sine 30. Okay, mu2 value given as a root 3 and sine 30. From this, you can get R1 value. R1 is the angle at this point. We can get R1 value, which is equals to 1 by root 2. Okay, from that R1 is equal to 45 degrees. We got it. Okay. And next, if you see, if you apply Snell's law at point P, because we need to find the angle theta here. And we need to prove that condition, like they have given a question in this question given. We have to find the value of this function. Just I'll write you that function. Okay, this is what we need to find in the question. They're given in the question, if theta equals to sine inverse root 3 by 2 sine pi by b, beta. We have to find beta value. If theta is equals to sine inverse root 3 by 2, sine pi by beta, we have to find the value of beta. Then to find the beta value, we can go ahead with, okay, Snell's law at point P. Okay, if I apply Snell's law at point P, then, okay, at point P, light ray entering from air to prism P1. Air to prism P1. Okay, then apply Snell's law at point P. Okay, 1 sine theta equals to mu1 sine r. But we know that r plus r1 is equals to 60 degrees. R plus, this is the r plus r1 must be equal to 60 degrees. That is the angle of prism which is given in the question. Okay, from this we can get r value. We already got r1 value 45 degrees. R1 value if we substitute, okay, r plus r1 value, okay, is equal to 60 degrees. R1 is equal to 45 degrees. We'll get r value 15 degrees. Then we can apply Snell's law. Okay, we'll go ahead with the Snell's law at point P. From this, we can write sine theta equals to root 3 by 2 times sine 15 degrees. Okay, sine theta equals to root 3 by 2 times sine pi by 12. 15 degrees means. Okay, as per the question, they asked us to find out beta value. Question they asked us to find the beta value. We can find easily. Beta is equals to 12 from this. That means it's a simple question, but you should know about the condition for minimum deviation to solve this question. Okay, after knowing the condition for minimum deviation, you can apply Snell's law at point P and point Q directly. Okay, what is the minimum deviation condition? We all know that, okay, through any prism, like through equilateral triangle prism, if R1 equals to, like, minimum deviation condition R1 equals to R2, which is equals to A by 2. From that, we directly got R2 value. Then we can easily, after we got R2 value, we apply Snell's law at point Q, Snell's law at point P. Then we can simplify, then prove that value theta equals to sine inverse root 3 by 2 times sine pi by 12. That's all about this question. Sir?
Thank you for the explanation, sir.
Yes, sir.
I will again invite the attendees to raise their hand if they have any doubt on this question or they would like to discuss anything more in it. Okay, I think, sir, nobody seems to have a doubt. So, yeah. So I think we can move ahead with the next question.
Yes, sir. Thank you, sir.
I think Gautam sir is ready. I'll invite Gautam sir to present the next question.
Yes, sir.
Yeah, so good evening, everyone. So
Good evening, Gautam sir.
I will take up the next question, which is based on. Yeah, am I audible?
You're audible. I was just asking, how are you?
Yeah, I'm fine. Yeah. How are you,
Okay.
sir?
Welcome to the session, sir.
Yeah.
So which topic are we discussing this question from?
So it's an induced EMF question from DMIS.
Okay. Great. So please go ahead with your explanation, sir.
Yeah.
You're audible.
Let me just.
Once you share your screen, if it is not visible, I'll let you know.
Yeah, sure, sir. I hope the screen is visible, right? Yeah.
Screen is visible, sir. Please go ahead.
Yeah, okay.
But
sure, sir.
Achha, you have written the question as well. Great. Thank you. Please go ahead.
Yeah, I've already written the question down. Yeah. So here the question given is loop is moving with a constant speed v, and the above triangle is the what is the loop given here. So this one right here is the loop. So as this loop moves, we have to find what is the EMF induced once it has gone down by a distance of d. So let's try to see what happens when the loop goes down. So when you draw the diagram here, say after some time, so initially if you notice the two ends are coinciding. So after some time when the loop has come down by distance x, I can see that the tip of this loop would have moved down by a distance of x from the initial position. So initially it was at this level. So when this loop has come down by a distance of x, I can see that the total region where of the loop which is inside magnetic field is going to be this part. So I'll have to calculate what is the area of the loop which is inside the magnetic field. So in order to do this, I can also like zoom into this part. So what we have here, if you notice the geometry, you have this part is 60 degrees and this is also 60 degrees, right? So the information is given in the question that these are 60 degrees. So it's an equilateral loop. So the other angle is also 60, vertically opposite. Now here, these two angles have to be, like if you notice this part, what we end up getting here is actually a rhombus. Right? Because the loop as well as the region, all four are part of the, you can say this is an equilateral triangle, and so we get all three, these two sides are equal and that's equal to the third side, and this angle being 60 degrees, we also get that the other triangle is also equilateral with the same, both the triangles are equilateral triangle with a common base. So what we end up getting here is a rhombus, all four sides being equal. So my objective is to find area. So when we write area of this, you can either find the area inside as 2 times the area of the two triangles, or I can also write that as equilateral divided into two equilateral triangles and find the area. Or since we found it's a rhombus, we can write the area as product of the two diagonals, which will be x into this length y. So I can see the two diagonals of this rhombus are x and y. So in this case here, as you can see, this being the one diagonal y and this being the other diagonal. So I just need to find what is the length y. So in this case, I can write this length, this angle is 60 degrees. So I can calculate what is the length of this. So tan 60 will be equal to x divided by this opposite side divided by y by 2. So I can write this as x divided by y by 2. So 2x by y is going to give you root 3. Or we get the value of y as 2x by root 3. Right. So this part is from the geometry. You just have to calculate what is the area of this region. So once you get that the rhombus area is product of the two diagonals, I can just write this value of total area which is inside the magnetic field as x multiplied with y, which is 2x by root 3. So 2x square divided by root 3 will be the total area which is inside the magnetic field. Right. So to find the EMF induced in this loop as it's moving, so I can say only the area of this loop inside the magnetic field will change. The magnetic field is uniform magnetic field and it's in constant displaced. So I can write the value of EMF induced as d phi by dt, or that is d by dt of magnetic field into area. Since the magnetic field remains constant here, area of the loop which is inside the magnetic field is changing with time. So I can write this as dA by dt. So we got the value of area as 2x square by root 3, and my objective is to get the EMF in terms of the distance traveled by the loop, or EMF in terms of the distance x, which is why we have gone ahead and found the area in terms of x. So here I can write this as B into, so d by dt of two x square by root 3. So I can write this as B into 4x by root 3. Right. So you can notice here the objective is to plot the graph between EMF and the distance traveled by the loop. So we find that the EMF y is directly proportional to x. The graph that we are going to get here is a straight one. Okay. So I hope this part is clear to everyone. Are there any doubts in this? Yeah.
I think it is clear, sir. Nobody has raised a hand.
Yeah.
To ask any question. Cool. Thank you for the solution, sir.
Yeah. Thank you, sir.
Let's see if we are ready with the next question. Next, I think. I think Ram Subramanian sir is ready, or Satyanarayan ji. Professor Satyanarayan. Ram sir. Sarji, are you ready with the next question? I think.
Yeah, I'm ready.
So minus.
You're on mute.
Just give me a couple of minutes.
No, got it. So for all those who are joining us from other platforms other than this live discussion, I invite you to join us on this webinar to ask your questions. The simple process is basically to go through the website. The link for that website I have shared on the chat. I am sharing that link again. It is FIITJEEglobalschool.com/JEE ADV 2024. So I am sharing that link on the chat again, or rather I'll show it on my screen as well. I think that would be a better.
Right, SSG?
Oh, you're ready, sir?
Yeah.
Okay, great. Good.
So,
I'll continue with this after Saurabh sir has discussed this question. Thank you, sir. Over to you.
Right, sir. Thank you, SSG. Just a minute. I will load the question. I'll check the question. Yeah.
Yes, sir. Hello.
Maybe if the student want to, in fact, we will not be able to track them through YouTube chat. Again, I'm saying that if the student want to have a tracking session, they can log into FIITJEE website.
I hope I am audible.
Yes, sir, you are audible and your screen is also visible.
Right.
Yeah,
so, now I'll be taking two questions. So the first question is like, say, if the question says there are two particles. One is projected with a velocity v0.
सौरभ जी बैकग्राउंड में कुछ वॉइस आ रहा है.
Okay. Just a I hope now it's okay.
Perfect.
So there is one velocity v0 and there is another particle projected with a velocity v1. This is at an angle theta naught and this is at an angle theta 1. It says that when theta naught and theta 1 are 45 degrees and 45 degrees, then T1 is the time taken to collide. Okay. Then if theta naught, theta 1 are 60 degrees and 30 degrees, the time is T2. Find T1 by T2 square. Right. So let us see if we have this two particles projected. We know that the relative acceleration of these two particles is 0 because both are under the same acceleration g, which means that if their relative velocity is along the line joining their initial positions, if their relative velocity is along the line joining their initial position, then they will collide, which means, suppose I say this is particle A and this is particle B, then V0 minus V1, V0 vector minus V1 vector is the relative velocity must be in this direction, V relative. Okay. Right. So this is V1. So this angle is theta 1, which means their components which are perpendicular to this line must cancel each other. So this is V0 sine theta and this is V1 sine theta. And the component of velocity along this direction are V0 cos theta naught, so theta naught and theta 1 plus V1 cos theta 1. So I can write the time T1 is the length is say L. So L divided by V0 cos theta naught plus V1 cos theta 1. And since the component must only be along AB, that means perpendicular component, these two will cancel each other, which means I can write V0 sine theta naught is equal to V1 sine theta 1. This is equation 1. This is 2. Okay. Given theta naught equal to theta 1 equal to 45 degrees. That means V0, therefore V0 is equal to V1. Put it in 1. So what is T1? T1 will become L divided by V0 cos, what is theta naught? Theta naught is given to be, you see, theta naught value is given to be 45. So 1 by root 2 plus V0 by root 2, right? It is V0 by root 2 plus V0 by root 2, which means this becomes L by root 2 V0, right? Let's come to the second one. By the same logic, time T2 would be equal to L divided by V0 cos theta 1 plus cos theta naught V1 cos theta 1 in this case, and we know that V0 sine theta naught is equal to V1 sine theta 1. So V0 sine theta naught, in this case theta is naught is given to be 60 degrees and theta 1 is given to be, so sine 60 is root 3 by 2 and V1 into sine 30 is half. Okay. So what is V0?
What is V naught? Can be written as V1 by, or V1 can be written as root 3 V naught. Simple. So I put it here, L divided by V naught cos 60. Cos 60 is half plus V1 is root 3 V naught into cos theta 1. Cos theta 1 is, theta 1 means 30 degrees. Cos 30 is root 3 by 2. So if I do this, it would become L by 2 V naught. So what is T1 by T2? Sorry. T1 by T2 whole square I have to find out. Right. So T1 is L by root 2 V naught divided by L by 2 V naught is 2 V naught by L. Right. Whole square. That is root 2 square equal to 2. Right. Is it clear?
Nobody has raised their hand, sir. I think it is clear.
We'll go to the next question in that case.
Yeah.
Ashish.
Yeah, sure, sir.
The next question is from heat and thermodynamics. Now, heat and thermodynamics becomes an important part. Every year, questions are asked from it. And the question that has been asked in this case is quite a simple question. It's from the specific heat capacity. The question says that if the specific heat capacity is given by kT, then if we heat 1 kg of a substance to raise its temperature from minus 73 degrees centigrade to 27 degrees centigrade, heat required. Okay. So heat, this substance, the total heat required is N K. Find N. Right. So we know that heat required would be equal to mass into specific heat capacity into dt. Right. So in this case, MC is KT dt. I will integrate this to get the total heat. And what are the limits? Minus 73 degree. But we need to get it in terms of Kelvin. Is 273 minus 73, that is 200 Kelvin. And 27 degrees centigrade is 273 plus 27, that is 300 Kelvin. So the limits would be from 200 to 300. So if I solve it, M is 1 kg into K, this would be T square by 2 with limits 200 to 300, right? We get K by 2 into 9 minus 4 into 10 power 4, right? So if I write 2.5 into 10 power 4 K joules. So this amount would be heat required. So N value is this, right? Did you understand? I hope the question is clear and answer to solution.
Yes, sir. I think there are no questions being raised.
Right. Okay.
So
Thank
we
you.
can move ahead with that. Thank you, sir. We can move ahead with the second question. Next question.
Sure.
Yeah. So I think Kalyan sir is next in line. Inviting Kalyan sir to share his screen and discuss the next question, sir. So, sir, you can unshare your screen.
Yes, sir. Am I audible?
Yeah, you are audible, sir.
Right. Thank you.
Please
So
go ahead,
welcome
sir.
back, students. And we got one more question from your units and dimensions, which is very much scoreable for all of you. Now let us look at that question where they said that the charge Q and another variables, that is the permittivity in free space epsilon naught and Planck's constant h and speed of light in vacuum c. By using these four variables, one more dimensionless quantity has been found. Now we have to find how the dimensionless quantity, let us say that quantity is denoted by letter Z. How that dimensionless quantity is dependent upon these four variables: charge, permittivity in free space, Planck's constant, and velocity of light in vacuum. Now, let us say the order of charge is A and the order of the permittivity in free space. I think they have given some variables. That is, for charge, the order is denoted by alpha. For permittivity in free space, the order is denoted by beta. And for the Planck's constant, the order is gamma. And for speed of light, the order is delta. You have to find what are the orders alpha, beta, gamma, and delta. It's quite simple. Now you know what are the dimensions of this charge Q. The charge dimensions Q can be written in terms of amperes and time, as ampere into time gives the dimensions of charge, which is coulombs. Likewise, the dimensions of epsilon naught, we can retrieve the dimensions of epsilon naught from the formula K is equals to, that is, force is equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. Now from there, let us find what are the dimensions of this epsilon naught. Force is equal to 1 by 4 pi epsilon naught of Q1 Q2 divided by R square. The dimensions of epsilon naught will be directly proportional to the dimensions of force F into R square divided by Q square. The dimensions of force is nothing but mass into acceleration, kg, that is m, acceleration length t power minus 2. Whereas dimensions of R is length L square divided by Q square, which is ampere square into time square. From here, we know what are the dimensions of epsilon naught. Let us write them down separately here. The dimensions of Q is 80, already written. The dimensions of epsilon naught is m into L cube into t power minus 4 times a square.
A minus 2, sir.
A power minus 2. Thank you very much, Ashish sir. So
Okay.
A power minus 2. And
Easy.
then we have dimensions of Planck's constant. We can find it out by using this relation. That is, energy E is equals to h times of Planck's constant times of frequency. Now you know the dimensions of energy is nothing but force times displacement or distance, we can say. So force we already know, that is kg meter per second square into length. Use the dimensions of energy is equals to dimensions of Planck's constant times frequency. Frequency is t power minus 1. So we can send it to this side. This is t power minus 1. So you can write down the dimensions of Planck's constant. H is nothing but m L square
T minus 1.
T power minus 1. Likewise, we can also write down the dimensions of speed of light, which is L T power minus 1. Now, you have to find out these powers alpha, beta, gamma, and delta. Now, for which I can write down the dimensions of amperes in that final Z must be equal to 0. The dimensions of amperes must be equal to 0. The dimension power must be equal to 0. Now, from this, we know that ampere will get it in this charge Q. We'll also get it in this epsilon naught. So this is Q power alpha. Alpha times 1, which is alpha, plus we have epsilon naught power beta. That beta is multiplied by -2. So alpha plus -2 beta must be equal to 0. Now we found out the relation between alpha and beta, which is equals to alpha is equals to 2 beta. And thus, next, we can see the odd one, that is easy one, that is mass. Mass is also dependent upon only two things, right? Mass comes from this epsilon naught and the Planck's constant. So Planck's constant is raised to the power of beta. So by writing the dimensions or the order of mass to be 0, I can write beta epsilon naught power beta, which is m power beta, plus h power gamma, which is m power gamma. Beta plus gamma must be equal to 0. So we can get beta value is nothing but minus gamma. Right. Now, next, we can look at the other one. 1 minute. Here we have beta power minus gamma, and then we have dimensions of length, which is c, and then it also depends upon h, it also depends upon epsilon naught. Now c is raised to power delta. So by writing the dimension order of length to be equal to 0, we can write c power delta length power 1, that is c power delta we have, plus h power gamma. In h, order of L is 2, so that is 2 gamma, and then we have length is also present in this epsilon naught. Epsilon naught is raised to the power beta. In this epsilon naught, L is raised to power 3. So plus 3 beta must be equal to 0. Now here we can write down further the dimensions of time or the order of time must be equal to 0. So time is present in charge Q. So alpha plus epsilon power beta, which is minus 4 beta, plus h power gamma, which is minus gamma, plus c power delta, which is minus delta, must be equal to 0. Now by solving these 4 equations, equation 1, equation 2, equation 3, and equation 4, we can find what are the relation between alpha, beta, gamma, and delta. Now let us see how that turns out to be equals to. Alpha is nothing but 2 beta, and beta is equals to minus gamma. So I can write alpha is equals to minus 2 gamma, whereas beta is equals to gamma. Let us keep gamma as it is. Now let us find out what is the value of delta. Now from here I can find delta. The delta value
is equals to minus gamma,
will
right?
be equals to minus 2 gamma plus 3 beta, where beta is equals to gamma. We know, sorry, beta value is nothing but minus gamma. We have beta value is nothing but minus gamma. So here we'll get delta value as minus 4 gamma and gamma as gamma. I hope this is clear, sir.
Yes, sir.
Now I have one more question with me. So shall I proceed with that question?
So I think just one thing, the
Yes.
doubt is, see, beta is equals to minus gamma from the second equation, right?
Yes, sir.
So if we put beta equals to minus gamma, it comes to be delta plus 2 gamma minus
Okay,
3
yes,
gamma.
yes.
So 2
Thank you
gamma
for
minus 3
correction,
gamma
sir.
means minus gamma, sir. So
Yes,
delta seems to be equal to gamma, sir.
yes, yes, yes. Thank you very much again, Mr. Ashish, sir. So this is minus 3 beta. So here we have plus 3 beta, that is
Yes, sir.
3 gamma minus 2 gamma, which is
Hmm.
equals to gamma. The value of dou is equals to gamma. Right, thank you.
Okay, sir.
Yes. So shall I proceed to the next question, sir?
Yeah, sure, sir. I think, yeah.
So the next question, I'll just read out the question that has been provided to us by one of our students. So a point source emits an unpolarized light. Let us say there is a source S, which is emitting an unpolarized light. And there are 2 points in space, point A and point B, such that intensity at point A divided by intensity at point B is equals to 2. This ratio, intensity at point A divided by intensity of point B, is 2. Now, in this scenario, 2 polarites have been introduced just before point B. Now, here we are introducing 2 polarites. Here is one polarite, and here is one more polarite. Now, you are introducing these 2 polarites here, such that their pass axes are 45 degrees with each other. The pass axis of one and pass axis of the other makes an angle 45 degrees with each other. Now you have to again calculate this ratio, that is intensity at point A to intensity at point B after these polarites have been introduced. Now, when these polarites are introduced just before point B, intensity at point A does not change. Intensity at point B may vary. Let us see how it varies. Now, the light that is entering these polarites will have intensity of I by 2, IA divided by 2, because intensity at point B is nothing but intensity at point A divided by 2. Now, since the polarites are being introduced after the light has been passing through point A, now the intensity of point A does not change because of introduction of these 2 polarites. Now, just before entering these polarites, the light will have an intensity of IA divided by 2. And this is an unpolarized light. Now, when this unpolarized light passes through a polarite, its intensity will become half, and it becomes a polarized light. It becomes polarized, and intensity will become half of this unpolarized light, which means IA divided by 2 times of half, which is equals to IA divided by 4. Now, its electric field of this polarized light will be along the pass axis of this polarite. Now, when it passes through this polarite 2, then the electric field of that polarized light and the pass axis of this polarite will be making an angle 45 degrees with each other. So the intensity that will be coming out, let us say it is I dash. I dash will be equals to this intensity before entering this polarite, which is IA by 4 times of angle between the electric field of this polarized light and the pass axis. So that is 45 degrees in this case. So this will be equals to IA by 4 times 1 by 2, which is equals to IA by 8. Now they are asking us to calculate after passing through this, after introduction of these polarites. Now you have to again find out what is the ratio of IA divided by IB. Now we have seen that because of introduction of these polarites, IA does not change, whereas IB now becomes IA divided by 8. So this ratio will become 8 after the introduction of these polarites. I hope you have solved both of these questions accurately. And over to Mrs. Dani, sir.
Thank you, Kalyan sir. I think Raghuram sir is also ready with the next question. We can move on to the next one.
Hello, sir.
Raghuram, okay, sir.
Hello, students. We'll go to the next question. The question that we have received from the students is from electrostatics. As you can see on the screen, the question is, we have a cylinder. There is a cylinder. There are two flat surfaces, flat faces, as well as the curved surface we have got. Now, the question is that you got at the center of the cylinder, at the center in the sense on the axis, approximately means the geometric center, there is a charge Q that is placed. And we have divided this into, means the structure is such a way that the cylinder is made into the parts as shown. There is one cone seen here with the semi-vertex angle theta. There is another inverted cone exactly of the semi-vertex angle theta is given. If theta is equal to 30 degrees, it is given the flux through the curved surface is phi. Now, the angle theta is varied to 60 degrees. Angle theta is varied to 60 degrees. Accordingly, the dimensions of the cone are changed. Then, dimensions of the cylinder are changed. Now, for theta is equal to 60 degrees, the flux through the curved surface is phi by root n, find n. So, if theta is equal to 30 degrees, flux through curved surface is given to be phi. In terms of the phi, what will be the flux if theta is given to be 60 degrees? So this is also one of the questions which we used to generally solve when we prepare for FIITJEE Advanced. Now, what we can say is, we remember, if at all, we have got a cone like this, and we got a semi-vertex angle theta, the charge is located here. Then the flux through the flat surface is, let's say, phi 1 is equal to Q by 2 epsilon naught multiplied by 1 minus cos theta. Theta is the semi-vertex angle, as you are understanding, students. So flux is this. Now what we are going to do is, for the given case, you understand that there are two cones. Hence, let me write exactly. We know that the total, if I want to find out the flux through the curved surface, flux through the curved surface is the total flux, that is Q by epsilon naught, minus the flux through the cone 1 and cone 2. So we are writing here the flux in the first case, case 1, we have a flux phi is equal to, through the covered surface, of course, which is Q by epsilon naught minus Q by 2 epsilon naught multiplied by 1 minus cos 30 degrees. There are two such cones. So I'm writing here like this. So first case, flux is equal to, with 30 degrees cone is what we are talking, Q by epsilon naught minus, this is Q by 2 epsilon naught multiplied by 1 minus cos theta is the flux through one cone multiplied by, there are two such cones, and hence we have got it this. Then I can take it to be Q by epsilon naught taking common. Then you can write, we understand that these two and these two got cancelled. So it is Q by epsilon naught is what is left there. So Q by epsilon naught 1 minus 1 plus cos 30 is root 3 by 2. This is equal to Q by 2 epsilon naught multiplied by root 3. This is what I would take as equation 1. Then the next one is case 2. For case 2, flux, let's say some phi dash is equal to Q by epsilon naught is the total flux. Again, for this, when theta is equal to 60 degrees, to get the flux through the curved surface, we have to subtract the flux passing through these two cones. So I am subtracting the flux passing through the two cones like this. It is q by epsilon naught. Of course, it is q by 2 epsilon naught multiplied by 1 minus cos 60 multiplied by 2. So that is what I am writing as q by epsilon naught minus q by epsilon naught multiplied by 1 minus 1 by 2 is 1 by 2 is what we have. So it is totally q by 2 epsilon naught. This is equation 2. So from the above equation 1, what we would write is q by 2 epsilon naught is equal to 5 by root 3 is what can be written. Therefore, this becomes phi dash is equal to q by 2 epsilon naught means 5 by root 3. So our answer is the value of n is nothing but 3. So this is one of the, yes, definitely, because you are preparing for advanced means you would have definitely solved this type of questions. I'm hoping that you had solved this question in the exam. If anyone have a doubt, you can please ask, raise hand and ask.
It seems that the students have they got the question, the solution
Yeah.
clear.
Fine. Very good, students. Very good. Then, Ashish sir, please
Yes, sir.
take over.
Yeah, sir. I was just saying that your question and the solution is quite nicely written, and it was very easy for me to also follow. Thank you for such a clear solution, sir. Just one thing I want to mention to all the
Thank you,
people
sir.
who are, yeah, you're welcome, sir. Just one thing I want to mention to the people who are attending the session. I think based on the questions that we have received so far, we are soon going to release the number of the list of these questions with the solutions, uh, and we'll come up with the where we are going to basically release these answers. So let's go to the next faculty, Professor Venkat. I think he's ready with the next question. Professor Venkat, are you ready with the solutions? Yeah, please unmute yourself.
Yes, sir. Now the next question, I'll share the screen. Give me a minute.
Sure, sir. Yeah.
The question is called.
Sir, just a minute. Okay, it's logged out from the like.
No issue, sir. Please take your time.
Yes, sir. Yes.
Mhm.
Can I use Saurabh sir tab, sir? No problem.
Yeah, sure, please.
Okay, next question. This question from two topics actually.
So request you to please share the question.
Yes, sir. Sir, I am writing question.
Yeah.
Okay, a ring of radius r is pivoted or fixed at the circumference at one point P, a charge Q is fixed. That means there is a fixed ring, and at one point on the circumference of the ring, a charge Q is fixed. And given that another charge diametrically opposite at opposite point is fixed, another charge. Given that diametrical opposite position, opposite point, another charge is fixed, another charge of Q is fixed, another not fixed, actually it's free to move on the circumference of the ring. Another point charge is placed on the ring, it can move freely on the circumference of the ring. What we have to find in this question, if we slightly disturb the free charge means second charge, we need to find the time period of oscillation of this charge. Given mass of the charge is m, charge of this point charge is q, find the time period of SHM. Find the period of SHM. Now with the diagram, I'll explain some more detail this question. You can see. There is a charge. There's a ring first, a fixed ring. And at one particular point P, capital Q charge is fixed. This ring is also fixed. And diametrically opposite point, another point charge Q is placed. It is free to move on the circumference of the ring. Let us consider radius of this. That is also given in the data. Okay, radius of the ring is given R. When we slightly displace this charge, to here, we can take with respect to center. Suppose, for example, with respect to point P, if we consider it is displaced by an angle theta, with respect to center, it is displaced by an angle 2 theta. It is displaced by an angle 2 theta. Then we can consider this charge Q is displaced by an angular displacement with respect to center by an angle 2 theta. Then we have for exhibiting SHM, we need a restoring force. That restoring force provided by this Coulomb repulsive force between the two charges. Suppose at point P, the charge Q repel the free charge Q. That is in this direction. You can see in the diagram. Now this angle is also theta. Then we can resolve the angle. This angle is theta. Then this repulsive force component is F cos theta. And repulsive force component, another component is F sin theta. We know that for restoring force, out of these two components, F cos theta can balance the normal force on the charge. F sin theta provides the restoring torque. For this point charge, if I write torque equation about C, if I write torque equation about C,
We are yet to receive the questions.
We have a component of force which provides the torque, that is F sin theta. About C, the perpendicular distance is R, which is the restoring torque for the point charge, which is equals to moment of inertia of this point charge, the charge which is exhibiting SHM, about C into alpha. But here, generally, student might do mistake. We are writing torque equation about C, then the angular displacement of this point charge we must take about C. That angular displacement must be 2 theta, not theta. That's where many of the students will go wrong. Okay, let's see. Now, let's define one by one. Okay, let's try to find what is the separation between the two charges and find the force between the two charges. From this diagram, you can see if you draw a perpendicular line here, R component will be, this is the R cos theta. We can see from the similar triangles, this is also R cos theta. The separation between the two charges at any instant is 2R cos theta. Then I can define the force F equals to, I can write KQQ by 2R cos theta whole square. This is the force. This is the force which is acting on the charge. Now, and we also know that moment of inertia about C for a point charge, that is mr square. But we are dealing with SHM. In SHM, we are always deal with simple harmonic motion. We always deal with the small angle approximations. For small angle approximations, we can take, okay, sine theta you can consider as a, for small angle theta, cos theta you can consider as a, for small angle it is 1, for small angles. Okay, then we'll substitute, we have all the values. Now we'll substitute in the torque equation. We'll try to find what is the angular frequency of this charged particle, free charged particle. Then if I substitute the value F KQ square by 4R square, cos square theta value, we already know that for small angles, cos theta value 1, can directly write this. Then, or else first let me substitute the complete value, then I'll take the approximations. That means I can write cos square theta into, okay, torque equation, as for the torque equation about C, into sine theta. Perpendicular distance is R, is equals to I about C is mr square into alpha. Then I'll apply small angle approximation. We'll be getting KQ square by 4R square. Cos square theta, you can neglect, you can consider as a 1. Sin theta, you can consider as a theta into R is equals to mr square into alpha. From this, I can get alpha value. Alpha value is equals to KQ square by 4R cube into M into theta. Okay, this is the step where many of the students goes wrong, because they'll directly compare with alpha is equals to omega square theta. But you need to understand here, we are writing torque equation about C, not about O. About O, the angular displacement is theta. About P, angular displacement is theta. But about C, we wrote torque equation. About C, that angular displacement is 2 theta. Then we have to modify this form. We can write alpha equals to, I multiply by 2, divide by 2, so that I can get KQ square by 8R cube M into 2 theta. This is the final result. We can compare this result with our angular SHM equation, condition for angular SHM equation, that is equals to alpha is equals to, I'm writing magnitude only. Okay, magnitude of alpha is equals to omega square into angular displacement 2 theta. From this, I can get a value of omega is equals to angular frequency KQ square by 8mr cube. From this, you can get a time period also, t equals to 2 pi into root 8mr cube by KQ square. This is the final result. I hope students, you understood, okay, where you will go wrong. Okay, and also it's very clear. Okay, if any doubts, let me know. Sir.
Thank you, sir.
Any
Thank you
doubts?
very much, sir, for the detailed explanation.
Yes, sir. Yes,
and letting students know where they can go wrong and how to interpret the question and definitely the answer.
Yes.
Thank you, sir. I now invite Saurabh, sir, to.
Thank you, sir. Thank you.
Yeah, thank you, sir.
Hello, everyone.
Yes, sir.
So the next question that I'm going to take is from fluid mechanics. Generally, students find to fluid mechanics little uninteresting. Some students find it difficult.
Yeah, I am one of those. I used to be very afraid of fluid mechanics.
We trust so much on mechanics part that the
Yeah,
chapter thereafter becomes little
very less
uninteresting
time.
to the students, maybe. Student perspective also in mechanics, there is so much to do. Fluids, we have limited scope as far as JEE syllabus is there. And okay, so let's get back to this question. The question says like, there is
There's some background noise, sir, coming
yeah.
from.
So let's do, there is a tank. Okay. There is a tank and there is a small audio whose cross-sectional area is A, and the cross-sectional area of this tank is capital A. It is filled till a height h. Okay. And this is kept on a platform of height capital H. Right. It's given that h by capital H is, sorry. Hello.
Recording in progress.
Can you see my screen?
Yeah, now it is not visible. It was visible just before.
Okay, just a minute.
Yeah, it's visible now.
Yeah. Right. So it is h by capital H by small h is given to be 16 by 9. Right. And similarly, there is another tank of same dimension, everything. There is no difference. This cross-sectional area is A. Here, same cross-sectional, but now this platform is also same height. But now from here, a pipe is taken to the end. Like there is a pipe going here. Okay. This is filled with liquid. Now it's given that the time taken to empty is T1. T1 is the time taken to empty, and T2 is this time. Then you have to find T1 by T2. So this is the question. All of you understand. So let's see from here. This is H, this is capital H. Liquid will come out with a velocity of a flux. Let's say at any instant of time, this height is y. So root 2 gy would be the velocity with which it comes. Similarly, if it is y, but you see this column of liquid is also there. So here the velocity will not be root 2 gy. It would be root 2 g h plus y. Right? This is the velocity with which is coming. Now I use the continuity equation. A, that is the cross-sectional area of this tank, and the rate at which the water is moving down, that is dy by dt. I'll put a negative sign because the level of water is decreasing, is equal to A into root 2 g into y. Similarly, on this side, what will it be? A, same thing, minus dy by dt is equal to small a into root 2 g h plus y. Correct? So I can now integrate this minus dy by root y is equal to small a by capital A root 2g dt. So I will integrate this at t equal to 0. The height was capital A, small h. And at t equal to t, the height is t1. Similarly, on this side, what will I get? dy by root h plus y is equal to a by a root 2g dt 0 to t2. And on this side, again, h2 0. Okay. So if I integrate this, what would be the integration? Y to the power minus half plus 1 is plus half. So it is minus 2 root y limits h to 0 is equal to a root 2g by a into t1. So minus 2. What is root? If I put 0, it is 0. Minus h, minus will become plus root 2h, right? Into a by a root 2g t1 is equal to t1, right? So basically, I find t1 is proportional to root h. Let's see this side. It will become minus 2 root of h plus y with limits h to 0 is equal to a by into root 2g by a into t2. So what is t2? If I put the limits, it will become 2 times root of, when I put 0, right, it would be root h, and this side root h plus h. So it is root h plus h minus root h. Okay, that into a by small a root 2g. So now I find out t1 by t2. t1 by t2 becomes equal to root h by root of h plus h minus root of capital H. We know that capital H by small h is 16 by 9, right? So small h is 9 by 16. So it becomes 9 by 16 capital H under root divided by 9 by 16, 1 plus 9 by 16, 25 by 16. It will become 25 by 16 root minus root h, right? So if I put the values, this is 3 by 4. Root h will get cancelled. 25 by 5 by 4 minus 1. So that is 3. So what is the ratio of T1 by T2? 3. Is it clear?
Yes, sir. The explanation is quite simple,
Right?
quite clear.
Any doubt? Thank
Very
you.
simple. Thank you, sir. I invite Rama Subramanian, sir, to discuss the next question.
Hi all.
Hi, sir. Any issue with the net now?
No, everything is fine.
Okay.
I'm sure that after an exhaustive discussion of fluids question, the last thing that you would want is yet another fluid question. So I have only 50% bad news for you. In that case, this question is going to involve not just fluids, it's going to involve one of the most challenging concepts of fluids, specifically surface tension, along with yet another topic, thermodynamics.
Oh, wow.
So without further ado, let's jump right into the question. It says that a soap bubble is in a closed container with pressure P0, which is given, and excess pressure inside the bubble is given to be 144 Pascal. The pressure in container is changed to 8 P naught by 27. What is the new excess pressure inside bubble? And we have to assume all isothermal conditions. I hope question is clear to everyone. The thing is, when we are isothermally decreasing the pressure of closed container, then we can use isothermal conditions to find out what will be the new volume of the bubble. Let the original radius of the bubble be R. So when we say that the original pressure inside the bubble, the excess pressure is because of surface tension. I hope you know that excess pressure inside a soap bubble, you should all be learned it as delta P is equal to 4 times the surface tension by radius of the bubble. So the actual pressure of the bubble will now be the pressure of the surrounding plus the excess pressure. This times the volume, the original volume of the bubble. This should be equal to the new pressure inside the bubble, which is 8 P naught by 27 plus 4 P by R dash, which is the new radius, times 4 pi by 3 R dash. I'm simply applying the condition initial pressure into initial volume is equal to final pressure to final. And in order to proceed, we can first find out what will be the, and here for calculating the change in volume, we can assume that these terms are negligible compared to the pressure terms.
Sorry to disturb you, sir. This, like, I could not understand that P naught is written as 8 P naught by 27. Is it like a different pressure and you have written it as minus instead of equal?
No, actually, we are comparing initial pressure of the bubble multiplied by initial volume is equated to final pressure of the bubble into final.
Understood, understood.
And while calculating the radius change, we can ignore the extra terms 4T by R and 4T by R because they are given to be negligible compared to the original, the atmospheric pressure. So that when we are ignoring, then the problem becomes a straightforward case. When we cancel common terms, and since the excess pressure term is ignored, now we are allowed to cancel this P naught alpha. So now we can write R dash cube becomes R cube times 27 by 2. And when we take cube root, we get R dash is equal to 3R by 2. Now, an important thing to remember about ignoring negligible terms is these can be ignored only when you add them with something very large. For example, if you take 1 milligram, is indeed a negligible mass. 1 gram is a negligible mass. However, when you are talking of 1 gram of gold, even that 1 gram has an extremely high value. So when is it considered negligible is if you are taking 10,000 kg plus 1 gram, then if you call it 10,000 kg, it's not going to make a big deal. But if you are simply taking 1 gram, it is going to make it. Now here, why I'm telling you this is because when we are taking the excess pressure as a separate term, we cannot simply say that it's negligible. Only when you add it with a large number like 10 power 5 here, allowed to. Now they are asking what is the new excess pressure allowed. Now the original excess pressure was given to be 144. When you compare it with that, the new excess pressure cannot be. So how to find that is, this is where you consider the term that 4T by the original radius is 144 and 4t divided by the new radius r dash. Let it be some x. So now we can easily find the value by dividing the two equations. When we divide these two equations, 4t cancels and we get on the left hand side r dash by r is 144 by x. And since we have already got that r dash is 3r by, when we substitute it here and then cross multiply, we get x will be 2 by 3 times 1. Which you can do the calculation yourself and find. I hope things are clear.
Got it, sir.
Yeah, in case just to find closure, we'll write the answer as well. The excess pressure we are looking for is 96.
96.
Right then, guys. See you with another question.
Thank you, sir. Now I invite Venkat sir for the discussion of the next question.
Sir. Next question, I'm going to take from, again, it is also based on equilibrium question and magnetic field. Let me explain the question first. Let me share the screen.
Okay.
This is the question, like I'll write question. An infinite. Can you hear me, sir, clearly?
Yeah, there was an echo, but now it is good. Please go ahead, sir.
Yes, sir. An infinite long wire is placed in a uniform magnetic field, but this wire has a bend. Okay, infinite long wire is bent in the form of a circular loop. That means the question mean that like this. Let us say there is an infinite wire. Somewhere in the middle, there is a bend in the form of circular loop. Like this. Okay, this is the question. Now, initially this loop placed in a vertical plane. Initially this loop placed in a vertical plane. There is a vertical magnetic field. And there is a current flowing, let's say I, then I will come like this. Okay, this is the direction of I. Now they were asking us to find how current I passes through this infinite loop. Then this infinite loop indirectly, they are also mentioned that these two ends are like infinitely long. You assume that these are like fixed, like kind of fixed. And this wire can rotate, free to rotate. Like you can say this circular loop can rotate about this point. You can consider this circular loop can rotate because of the magnetic field. Okay, it can rotate about this point. You can treat like this entire infinite wire. You can treat like some kind of support. About this support, that loop can rotate. Okay. Now they also mentioned that the small part of the circular loop of mass m. In the question, it is given. And the radius of this circular loop also given as a r. That means overall in the question, what is given? Current passes through the loop is given I, and mass of the loop, circular loop is given m, and radius of the loop is given. Radius of the loop is given r. What we have to find actually here is find the question is find the angle subtended by the loop angle subtended by the loop when we switch on the magnetic field. When we switch on the magnetic field, that is the question. Now let us see, that means initially there is no magnetic field and initially the loop is in vertical plane. Now, okay, when we switch on the magnetic field and they are trying to say, maybe this question actually straightforward according to the option. They have given like what is the angle made, tan theta, in terms of mg and current and magnetic field. That means we need to find the equilibrium position, simply to say. We need to find the equilibrium position. That means at equilibrium position, if I take this loop in vertical plane in this direction, okay, we need to find the equilibrium position about this point P. If I consider the loop is displaced by an angle theta, suppose. It makes an angle, vertical angle theta with vertical. The plane makes an angle theta with vertical. There is a gravitational force acting mg downward. And there is a magnetic field. They mention it is vertically upward. Then the area, magnetic momentum vector, magnetic momentum of this current carrying loop is along the direction of area vector, that is m. We know already m value, how to define. M is equals to I into A, where I is the current passes through the loop and A is the area of the loop. It's I into pi r square. That is the magnetic momentum of the loop. Okay, now we can see clearly from the diagram, the B is in vertically upward direction. Then this angle is theta. This angle would be 90 minus theta. Then we can say at equilibrium position, we need to find the angle, how much angle it makes. That is what the question says. Then it's a straightforward question. We can just equate net torque about P is 0 at equilibrium position. Net torque about P is equal to 0. What are the torques are acting on this about point P? The torques are acting about point P is torque due to mg plus torque due to magnetic force, which is equals to G. Then let me write torque due to mg. That is, from the diagram you can see about P, torque due to mg. If I take the perpendicular distance supposed to be this. Perpendicular supposed to be this. That is, radius of the ring is r. Then we can resolve this as a r sine theta. Then I can write torque due to mg is mg into r sine theta, which is acting anti-clockwise direction. Torque due to mg, because about P, if we apply torque about P, okay, mg is acting downward, the torque would be anti-clockwise direction. And m bar cross b bar torque due to magnetic force, which is equals to minus m bar cross b bar, that is mb sine theta, then m into b into angle between the magnetic momentum and magnetic field. Okay, that is 90 minus theta. That's why I'm writing sine 90 minus theta. Net torque about P supposed to be 0 at equilibrium position. Then if I simplify this, small mg r sine theta is equals to mb cos theta. I also need to substitute the value of m, which is there on the screen. Value. If I substitute mg into r tan theta is equals to m value I into pi r square into b. Okay, if I cancel one r here, then I'll be getting tan theta value is equals to I pi r b by small m g. This is the final result for this problem. That means the question is pretty straightforward. Torque due to gravity and torque due to magnetic force must balance. Then they are asking us to find the angle subtended by the loop with vertical. Angle subtended by the loop with vertical, we have to find. This is the question. Okay. I hope, children, you understood. Any doubts, please raise your hand.
Yes, sir. I think it's clear to everyone.
Yes, sir.
No arms raised. No hands raised.
Sir, Ashish Dhyani, sir.
Yeah, thank you, sir. I think Kalyan sir is also ready with the next question. So I invite him.
Yes, sir. Thank you very much.
Okay, sir.
So we'll move to the next question received by one of our students. And this question is from Electrostatics. Now, let us see what actually this question says. Now, here in this question, there is a uniformly charged spherical shell of charge density sigma over its surface. And its radius is given as capital R. Now, here we have a uniformly charged spherical surface of radius R of charge density sigma, and near it there is a point dipole where the dipole moment of this dipole is given as p vector. Now it is meant, we can consider these dimensions of this dipole is very small and thus mentioned as point dipole. Now wherever we place this dipole, now this dipole will be under the influence of the external electric field. That is the electric field that is produced due to this uniformly charged spherical shell. Now, if this is how the electric field is, this electric field will create a torque on this dipole, and this dipole start oscillating, and we have to find out what are the time periods of these oscillations when this dipole is kept at different distances from the center of this sphere. Let us say the distance of this dipole from this spherical shell, from the center of this spherical shell is r. Now, in the options they have mentioned that if r is equals to 10r, what is the angular frequency of this dipole? If r is equals to 2r, what is the angular frequency of this dipole? And other two options tells us that whether this dipole will perform oscillations for all values of r or for only some values of r. Now let us look at this option C and D, where we need to check if this dipole will perform oscillations for all values of small r. Now, if you see in this case, the electric field due to this uniformly charged spherical shell at any inside points, this electric field will be equal to 0. Only for these points whose value of small r is greater than or equals to capital R, the electric field is similar to the electric field due to a point charge placed at its center. So when this point dipole is placed in this inside region, you see that the net torque experienced by this dipole will be equal to 0, and thus no oscillations will be performed by this dipole. So from here, for all values of small r, it performs oscillations is wrong option. Only for some values of r, it performs oscillations is the correct option. Now let us look at options A and B, where you need to find what is the angular frequency of these oscillations when the value of small r is equals to 10 capital R and the value of small r is equals to 2 capital R. Now we know that if this dipole is placed in an external electric field. Let us say the electric field is E and it is uniform wherever this dipole is present. Now here in the question, even though the electric field is not uniform, since the dipole is a point dipole, we can assume that its dimensions are negligible, and thus throughout the location of this dipole, the electric field can be considered as constant. And that electric field, if it is E, and the dipole moment, if it is making an angle theta with this electric field, the torque experienced by this dipole, E torque vector, the magnitude of torque can be written as, yes, the magnitude of torque can be written as magnitude of P bar cross E bar.
I got the point Q. So line passing to a point and
Sir, I think some sound is coming from the other.
X minus
I think there's a background noise, right?
Right, thank you. So magnitude of P bar cross E bar, which in this case is P E sine theta, is the magnitude of torque. Now you can see that torque on this dipole is acting in clockwise direction, whereas we can consider that its angular displacement, the dipole's angular displacement from the electric field direction is in anti-clockwise direction. This theta is in anti-clockwise direction, whereas torque is in clockwise direction. If you assign sign to angular displacement to be positive, that is, if we consider anti-clockwise direction as positive, then torque is negative in this case, which is P E sine theta. And for small values of theta, we can write the value of sine theta is approximated as theta. So this will be P E into theta, where theta is written in radians. And the magnitude of torque, now for this, I can write it as torque is equals to moment of inertia times angular acceleration, which is d square theta divided by dt square. Now, d square theta divided by dt square comes out to be equals to negative of some proportionality constant, which is in this case dipole moment times electric field divided by moment of inertia of this dipole times angular displacement. Now, since it is of the form d square x by dt square is equals to minus omega square times constant, by comparing those relations, we can say that this theta will also be performing an oscillations. That is, the theta will be varying sinusoidally with an angular frequency omega is equals to under root of P E divided by moment of inertia I. Now, as you change the location of the dipole moment, coming back to this dipole, if you change it to some other location, its moment of inertia I, its dipole moment P does not change, only the value of electric field changes. Now, let us find out what is the electric field due to this uniformly charged spherical shell at different points. That electric field is nothing but K Q, the charge on the spherical surface, which is sigma times of 4 pi r square divided by K, I can write it as 1 by 4 pi epsilon naught. Where the charge on this is 4 pi capital R square divided by the distance from its center, which is R square. Now, at a distance of R is equals to 10 R. Now, I can find what is the electric field due to this uniformly charged spherical shell. That electric field is equals to 4 pi cancels out. You have sigma divided by epsilon naught times of capital R square divided by small r square. In this case is nothing but 100 R square, which is sigma divided by epsilon naught times of capital R square is the electric field times 100 is the electric field due to this uniformly charged sphere at 10 R distance. Now we can find what is the angular frequency of the oscillations performed by this dipole at R is equals to 10 capital R. is equals to under root of P divided by I times of E. In this case, that electric field is sigma divided by 100 epsilon naught. Whereas at a distance of small r is equals to 2r, you can see the electric field is increased, and that will be equals to sigma by epsilon naught times of capital R square divided by 4 capital R square, and this is equals to sigma divided by 4 epsilon naught. From here we got it, the magnitude of electric field, where in place of small r we have substituted 2 capital R. Now the angular frequency of these small oscillations performed by this point dipole at a distance of 2 capital R is under root of P divided by I times of the electric field at that point, which is sigma divided by 4 epsilon naught. This is the angular frequency at a distance of 2 capital R. This is the angular frequency at a distance of 10 capital R. And for all the points where the value of small r is less than capital R, the net external, the torque due to this charge on this dipole will be 0. No oscillations will be performed. Now with this, we can mark, I think, from the options that have been given from the students, option A and option B matches correctly, and then option D, where only for the values of small r greater than capital R, this will perform oscillations. I hope all of you have understood this question. If you have any doubts, you can please feel free to pose it.
Thank you very much, sir.
Right. Thank you, sir. Over to Ashish, sir.
It seems, I think, all the questions that was shared by the students, we have exhausted them. I invite the attendees, if they have any questions that they would like to share with us, or they have any doubt regarding the questions that we have shared on the platform. Please raise your hand. Okay. Pawan sir, and all the faculty, are there any questions that we can share or we can discuss?
That's what I'm also asking on the WhatsApp group.
Yes, sir.
If people are, a couple of questions are there from optics, wave optics and all, but I don't know whether faculty got the time to solve it or not.
Okay.
There is one mechanics question also which is not covered, and then when one wave optics question is also not covered. We need to solve that. Is there any faculty member who has solved and ready to take it up on live?
So let's take like next 5-10 minutes and see if people have solved. Otherwise, we will close the.
Yeah. So you can just keep giving some general information to the anybody, if anybody is there. And
sure, sir.
Yes. We can.
Okay. Okay, sir. Thank you. Okay, so cool. So I think we have had discussions from all of the portions of physics. I think there was some question from modern physics. Then there was from SHM. Yeah, definitely electrostatics was there. Something from the Prism question from optics. Mechanics, it was there, units and dimension, I think, and fluid dynamics, definitely. Fluid mechanics. Yeah. I think there was some from waves as well, if I'm not wrong. Anyway, I think quite exhaustively covered by JEE. They have not left any portion from physics untouched. Right now, so I'm still waiting for some of the questions to be presented by the faculty. And till then, I think I can share some of the USPs that FIITJEE has, and FIITJEE has been able to pioneer. One of the things that I mentioned earlier was the test analysis. And for all those who are watching this stream now and were not present at that time, I'll just go through it again. So, in my during my preparation, this test analysis process was very, very helpful, because when I used to study hard, but sometimes I was not able to score well in my exams. But one of my teachers, who was a maths teacher, he basically introduced me to this process. And we after every test, we used to do this analysis. It was somewhat similar to this. Basically, the idea was, how many marks are you losing uh, through a particular mistake. Okay, let's say, for example, a calculation mistake. Now you can say that every time the calculation mistake will be different, but it is a calculation mistake nonetheless. That means it happened because of some ignorance, some uh, overlooking some aspect or some information, right? So we have to be more attentive. So if we are able to do that, then we will be able to avoid such kind of mistakes. And definitely double or triple checking your own answers or your own calculations helps you in in avoiding such kind of mistakes. So I was able to do that. And not only with calculation mistakes, one of the biggest things was that I was not really able to read the question properly, because I was always worried about completing the whole or attempting all the questions at least, right? And that is also important. I'm not saying that we should not attempt, but the point is, uh, after reading the question very well is very important, and extracting the actual correct information from that is very important. Also, when you read a particular question, it usually gives you an idea as to how much time it will take, or is it a question that you would want to attempt at that point of time or not. Because if you pick up a difficult question, and let's say it takes you 4 minutes or 5 minutes, and if you take uh, a simple question or an easy question, it takes you, let's say, a minute only. So you have invested 5 times more time for the same amount of or same number of marks, right? So that, I think, is not the right strategy. So it would be better if we are able to close those questions, finish those easy questions first, and then move on to the tougher ones. So I'll share an anecdote from my own preparation. It was 2006, and in 2006 there was this matrix match questions. They were introduced for the first time in the examination. And like, the matrix match was like, there can be any number of uh, options on the right for a single option on the left. So if there are two columns, A and B, for, let's say, first option on A column, let's say A1, we could have B1, B2, B3, B4, B5, all of them. So it was we had to solve like 5 questions for one option. And let's say if there were let's say 5 of these options on the left, then there were like almost 25 questions. So it was, I had never solved those questions. So my strategy of solving that question came from the previous one. So the first one was, I think, physics. When I attempted from these questions only, and uh, these questions were like +6 and 0 marks. Like, you could not lose any mark if you did the questions incorrectly. So for physics, I took these questions first and then moved on to the others. But the mistake that I made with mathematics was, I took these questions first for mathematics, and for almost 1.5 hours, I was solving these 4 questions only, which was like 6 marks each, 24 marks out of I think 180 or something. And that was the mistake I made. And in the next 30-35 minutes, or maybe 25 minutes, I don't remember, I just went on and solved all the easy questions that I could. So in that scenario, had I solved these easier questions first and then went on to solve those questions, the 4 questions for 6 marks each, then I think the marks that I had scored would be at least 10 to 15 marks more. And just imagine 10 to 15 marks more is almost 1200 to 1500 ranks. Let's say my rank was around 2000 something. So it would have been at least around 1000. So just one mistake and it cost me that much. So that is one of the things which I think everybody should keep in mind. Okay, so I think Pawan sir is ready with the question. Pawan sir, and now I invite Pawan sir to solve the next question. Take a second now.
Hello,
Pawan sir.
am I audible?
Yeah, you are audible, sir, but you're not visible as yet, sir.
Yeah. Yes. The FIITJEE official question paper has come. Even we can go for the official question paper solving tomorrow. But anyway,
Sir.
we'll wind up the session with this last question because
Yes.
time is also up. And then again, I think it will be difficult for many people to again complete this. So now I'll take up one question from wave optics.
So your screen is not visible, nor is your video.
Okay, 1 second. Just a minute.
Sure, sir.
Now is my screen visible?
No, sir. Your screen is, I think, you're connected with one ID only, sir. One device only. Is not.
Yeah. 1 ID only I'm connected. But is it visible now or is not visible?
No. It's not visible, sir. Sharing the screen, yeah, it is available to you as well, sir.
What is it? No, I don't know why it is not coming.
Mm-hmm. Yeah, you're visible, sir, now.
Yeah, I'm visible, but I don't know why this is not getting connected with when I'm trying to share here, it is going back. Some issues with. I'm sorry. I think some problem with.
No issue, sir. I think then, if in case because the official paper is also available now, we can discuss all the questions tomorrow only. We can close the session now.
Sure. Okay. Right. We'll close the session and then tomorrow can we start the session?
Yeah.
Right. Okay.
Thank you very much, sir. Thank you very much to Kalyan ji, Arvind Gupta ji, Gautam ji, Himanshu ji, Kalyan ji, Raghuram sir, Saurabh ji, and Srinivas ji for such an engaging session today. And I think the students who attended the session benefited from this. And thank you to the students who attended and patiently listened to the explanations given to us by our faculty. So with this, I think we can close and call it a day. Thank you, sir. Thank you, everyone.
Thank you, Ashishji. Thanks for helping us and being a very good host. Thank you so much.
Thank you, sir. Bye, sir.
Bye-bye.
Bye, everyone. Bye-bye.
Bye, sir.
Bye, sir.
Bye-bye, sir.
Thank you, sir.
Thank you, sir.
Bye, sir.
So shall I close this? Like if
Yes.
I then